so this would be the lesson for today. So we will be revising on 3 topics. I would say actually it's more like 4 topics because qualitative analysis and sort actually is like separate. Okay, but some schools teach as combined. Yeah, but it's about 3 to 4 topics for today. Then we will be going through the mock exam paper at the back. Yeah, so if you were to look at the revision kit, at the back of the revision kit, you will be seeing actually there are mock exam questions at the back. Yep, so make sure that if you haven't do it, try your best to complete as much as you can, because later I'll be going through the answer. Okay, so there's a mock exam at the back. Finish it as soon as you can. Yeah, by right actually should finish before coming for class lah. But in case you are not informed, yep, you try your best to finish it. Yep, then after I go through already, then I'll be giving you the answer key. Because the session today is only like 3 hours, then I got so many things to go through, right? Yeah, I need to like go through the notes. I also need to like go through the corrections. Yeah, that's why like in case you don't have time to write fast enough, maybe some of you all like write a little bit slower. If you can't finish your correction, no worries, because I'll be giving you the answer key at the end of the lesson. So you can actually go home and slowly copy down the correction lah. Yeah, then you can just focus on listening to my explanations. Okay then, so without further ado, let's begin with the lesson now. So as mentioned, the first chapter would be mole concept. So I will be using my slides to teach for mole concept. Then I will use the revision kit to teach for acid bases and salts and QA. Okay, so let me distribute this mole concept first. So for those online, for those of you who just came online, if you do not have this mole concept slides, you can download it from the QR code here. So for those online, you can download it now while I shall distribute the hard copy to the physical students. Okay, so for the online attendee should be done copying by now. I mean, sorry, should be done like downloading by now, right? I will pass to you girls in a short while. Yeah, cause waiting. Okay, so yeah, let's begin with the lesson now. Just to let you know that actually for this my first slide, right, is actually inside the revision kit. Yeah, so you can actually flip open your revision kit. There is a contents page. So you can refer to the contents page. The page for more concept is page 19. Yeah, so can you all flip to your revision kit page 19? So I'll be using both at the same time. I'll use the slides as well as the revision kit. So can everyone flip your notes now to page 19? Yeah, flip to page 19. Yeah, so flip your revision kit to page 19. Okay, so for the topic on mole concept, I believe some of y'all like find that like you are struggling in it, like you find that like it's like so difficult, like they can test like anything, like how do you know what kind of question will come out, then like how to prepare for your exam. So actually just to let you know that mole concept is not like they can test everything. Actually the style that they can test, right, is only limited to 7 types of questions. Yeah, so once you can master the 7 types of question, actually you should be okay with the topic already. Okay, so I start off with the foundation first. Yeah, of course, need to know all the formulas over here, right? Yep, so need to know that for the formula over here, the first one here is related to the Avogadro's constant. Take note that when question mentioned about number of particles, the particles over here, you have to be specific in your answer when you do calculation. So particles can be in various form. It can be in the form of atoms. So whatever that I'm annotating now, can you all follow and copy it down? Yep, so follow and write it in. So number of particles can be in terms of atoms, can be in terms of molecules, can be in terms of ions. Yep, so you have to read the question to see what it is. Later, I'll go through more example with you on how to calculate using the Avogadro's constant. Next, this is our favorite formula, right? Which is the number of moles is mass over mR, or molar mass. And for volume, take note that for this formula over here, it's only applicable for gas. That means if it is solid or liquid, you cannot use this formula. Yeah, so usually how I write it is, I write it as number of moles will be volume over 24. So this is another way to present it. Next, for concentration, you have to look at the units. If the unit is mole per dm cube, then of course you just follow the unit, right? Which is just mole divided by volume, because dm cube is volume. Then if the unit is gram per dm cube, then just follow the unit. It will be gram, which is mass, divided by volume. Then also need to know how do you convert between these two. So to convert between these two units, you can just go by this. So from mole, how to become mass? So from mole to become mass, isn't it you just multiply by the mR, right? Based on this formula here. Yeah, so mole times mR, you can get the mass. Then for mass, how do you become mole? So mass to become mole, you need to divide by mR. So these two units are actually interconvertible. Next, percentage U, percentage purity, and percentage by mass. So take note that as long as they are percentages, they are always in terms of mass. So you can highlight it. So once you see the word percentage, it would definitely be related to mass. That means your fraction, right, the numerator, denominator, it has to be in terms of mass. Like the actual U, it should be in grams, theoretical U in grams. Over here, mass, I think you already know is in grams. Here, they already mentioned the word by mass. So mass, then you see MR. MR is also like mass. So take note that whenever it's percentage, your fraction should always be in terms of mass. Okay, so give me a moment. I shall go to the printer to collect a few handout. Then I'll be back. So for those of you who just log online, yep. So here's actually the slides that I showed just now, right? This is the QR code. Can you quickly download it? I'll be back in less than 1 minute. So for the online attendees who just came online, should be done downloading the materials, right? Based on the QR code. Okay, so let me continue on now. So next would be that yep. So after you know the basic, which is the formula, then next is how do you study this topic? Yeah, so you need to know that for mole concept topic, it is mainly made up of the 7 question type. As long as you know the 7 question type, then likely you should be all right with it. Yep. So let's go through the 7 question types. Okay, so yep, can you follow me and copy it down? So types of mole concept questions. Okay, so if you were to flip your notes, then can you all take a look and tell me like what kind of question that usually you will encounter in like worksheets? What kind of question? So I'm not asking for formula, like what type of question do you need to solve usually? So what are the types of questions that you will encounter at formal concept? Any possible answer? Maybe I start off with my own student first. I start off with Jovina first. So Jovina, do you know what type of question I recently went through, right? Correct. So you have the question that is like about the molar ratio, which is actually the 4 steps of. How come it's not appearing? Let me try again. Yep. Okay. So it would be the standard 4 steps question. Yeah. So I hope you all still remember what are the 4 steps. Yeah. So the 4 steps will be usually the first step. What do you need to do? Those very typical kind of question. So what's the first step that you need to do? Okay, I continue on with Joivina because you finish the whole first point first. So what should you write first? Correct. You always start off with chemical equation, then followed by calculate the correct, calculate the number of moles because this topic is mole concept. So obviously you must calculate number of moles first, right? Out of all the things that you need to calculate. Yep. Then after you calculate number of moles already, then like what you said just now, mole ratio, then correct. So you answer the question accordingly lah. So maybe if the question asking you for maybe percentage purity, then you calculate percentage purity or if the question asking you for concentration, then you just calculate concentration. So you just answer the question accordingly. Then I just continue on. So I move on to Bodhi. So what type of question do you normally encounter when you learn this topic? I'll just go in sequence, just to let you all know, in case like you want to have like some mental preparation. You can also flip through the notes to see like what kind of questions. So do you know what other type of question do you encounter in mole concept? You don't know anything about mole concept? Percentage yield, yep. So that's one of the type of question, correct? So there are three types of formula that is involving percentage, right? Which I showed just now. So maybe Bodhi, can you like let me know which are the three formula that involve percentage, which is just what I just went through. So there's percentage, percentage yield, correct? Percentage purity, correct?
Percentage by mass second.
Yes, correct. Yep. So these are the three types of percentages question that you need to know. Okay, then next I move on to Jamie. What other types of question do you encounter in the topic of mole concept? The excess and limiting reagent, correct? That's good. That is like one of the killer type of question, right? Yep. So if, oh wait, how come my word's not appearing? Hold on. Limiting, okay, and excess reagents. Yeah, I'll just write in extra notes. Okay, by the way, for the last one, right, the percentage one, so as mentioned just now, whenever we calculate, it should be always based on mass. Then for limiting and excess reagent, how do you know that like a question is limiting or excess? Okay, if the question is like, friendly enough, they will say that, okay, part A, identify the limiting reagent and show your working clearly. So that's if the exam teacher is like, the teacher is nice in stating it clearly for you. But it's not always they will tell you that like, find the limiting reagent. Sometimes they will just give you a limiting excess question and they expect you to know. So how do you know that it's a limiting and excess reagent question? Is usually the quantities of both reactants are given. So they will usually tell you maybe like the volume of both substance or maybe the mass of both substance. So usually they will give you both substance. And then that's when you are supposed to go and identify. If they give you both, it is likely one might be too much, one might be too little. But if the question only give you for one substance, then that will be likely not limiting excess question anymore. Yeah, so that's how we recognize. No worries. If you not quite understand what this point I'm trying to tell you, I will demo it to you later. Here is just like a summary to show you what are the question types. Like more like listing down the checklist on what you need to make sure that you have studied. So once you study all these 7 types, then you are okay to go for the exam. Okay, and also need to know that for the limiting and excess, once you identify who is the limiting, you always follow the limiting reagents number of moles. So that means if you have the number of moles for both of them, you follow the limiting reagent. Then next, I move on to Yingshuan. So Yingshuan, do you know what other types of question that you have like done so far in mole concept? Yes, correct. The empirical and molecular formula table, right? Remember the table that you need to draw it out. Yep, so that's another question type. Yep, so this one I need to draw with table. So just to let you know, there's actually another question that also need to use the similar table, not only empirical and molecular formula. There's one more, which is called the water of crystallization type of question. What's water of crystallization type of question? It would be something like this. Like they said that it's like copper sulfate, CuSO4 dot XH2O. Have you seen such question before? Like the dot XH2O. So once you see like dot XH2O, that's actually the H2O is actually the water of crystallization. Yep, so for such question, you also need to use the same table in the empirical formula table, which is the usual, which is like mass, MR, mole ratio. Okay, then the last one over here is actually another type of question is called volume ratio. So volume ratio is only applicable for gases. Yeah, so if it's like liquid or solid, you cannot use this. So this is like a shortcut for gases. And one last question type was a formula that you see just now, right? So what was the first formula that you saw in the table on page 19? So what kind of question is that? What's the first formula that you see on the table? Okay, then maybe I move on to Zihan then. Yeah, so Zihan, what do you see for the first formula in the table? Yeah, correct. Number of particles. Yep. So the other question is about the number of moles of particles versus number of particles. So take note, okay, the answers are drastically different. Yep, so this would be your checklist. As long as you have completed all 7, like if you know how to answer all 7 types, then I would say that, okay, you can go for your exam already. Yep, like that. Done. Should be done copying by now, right? Because I paused here for quite a while. Okay, so I'll be moving on. If you're not done, maybe you take a screenshot. I'll be moving on in 3 seconds. 3, 2, 1. Okay, moving on. By the way, for those of you online who were asking about like volumetric analysis and titration, those would be under like the 4 steps. Yeah. So I would say that I've covered in under point 1. Yeah. Okay, so let's move on. Yep, so just now what I've written out is also shown here. Okay, so let's take a look at the different question types so that to see like how to solve for different question types. So just to let you know that for if you were to compare between the revision kit versus my slides over here, they are similar, just that for the revision kit, okay, let me show it to you. So this is the revision kit that you all have, right? Okay, so if you flip to page 19 of the mole concept, so it's just different way of presenting the contents. Yep. So if I'm at page 21 over here is just okay, it's just different teachers teaching style lah. So maybe some teachers like to teach you by how you link all the numbers together. So actually like maybe from a volume you can convert to mass, you can convert to like a moles. Yeah, so it's over here, this is like how you link all the formula up. But for me, my personal preference is I like to teach based on exam question type. Because you are sitting for your exam, you need to be able to recognize, okay, what type of question, then you know what kind of method to solve. Yeah, so that's why I actually present it in a different style. That's why I had this additional slides. So what I did was for the revision kit, it is actually just the answers itself. Yeah, but for my slides, I went to include the question for it. Yeah, so actually it's still the same. So it's like you can compare it side by side. Okay, so for this question over here, this is a very simple question. So this part I will skip. You can give it a try at home at your own time using the space over here. Yeah, so you just need to use the 4 steps. I'll use another question to demo to you the 4 steps. Okay, so no worries. After you're done trying, there is a model answer on the next slide. Then yeah, so all these answers you can actually write it into the so after you try it out, yeah, then you can write it in. So this would be the answer for the first section of the notes. Can? Okay, so then the one that I want to go through with you is this. So this is another question, but involving the same chemicals, just that the number differs. Yep, so for this equation, let's read together. They said that the chemical equation for the reaction between these 2 substances is as shown below. Then they show you this equation. And this equation is also found in your revision kit, right? If they were to mention that excess of this solid was added to this amount of sulfuric acid, and they were to ask you calculate the mass of this reactant over here, then how do you know how to solve it? So take note, okay, whenever it is the first question type, which is the 4 steps, this would usually be 50% of the question that will be tested. Yeah, so if you know how to do this, then like minimally, at least you know how to do half the question. So this kind of question need to know how to solve. Yeah, so what are the 4 steps? So step 1, you write the balanced chemical equation if it's not given. So for this question, they gave it to you, right? So okay, then don't need to write anymore. Step 2, since this mole concept topic, obviously the first step you should calculate is the moles, right? Yeah, so that's why first step, you calculate the number of moles. Okay, so after you calculate the number of moles, then you see which formula good to use. So you can refer back to the revision kit where all the formulas are at. You choose the appropriate one. So in this case, since they have given you like concentration and volume, that's why you should use the concentration formula. Yep, then you just get this number of moles. Then step 3 is the, as per usual, which is the mole ratio. Then you do the mole ratio. In this case, for the H2SO4, it is 3, right? And then your aluminium carbonate in front is like 1. So 3:1, then you copy down. This is for sulfuric acid. If this is 3 units, 1 unit is how much? Then step 4, you answer the question. So later, right, even when I go through more questions, sometimes you will see that other question type also need a combination with question type 1. Yeah, so sometimes they don't only test you this question type, they can mix together a few question types. So you get to see more examples later. Yep, so this is how you get the mass. And with that, we can fill in the table. Yep, so for the table, yep, so this would be the number of moles of the aluminium carbonate, and this would be the mass of the aluminium carbonate. So let's fill in the blank. Yep. Yeah, so actually, for this part over here, is just using the 4 steps. So you can fill it into the blank in the revision booklet. Yeah, so this booklet. Yeah, so inside there's some blank, right? Yeah, so can you fill in the blank now? So this is under point number 2 because remember I told you I skipped question number 1. Yeah, so this is question number 2. That's why it's at point number 2. It should be done copying by now. Okay, then done with part A. So now moving on to part B of the question. The question is still the same, but instead they are asking you to calculate the volume and mass of carbon dioxide. So this is still the same question type where you use the 4 steps. So you see, again, chemical equation settled. Find number of moles. So this was calculated in part A. Then you just move on to mole ratio. So mole ratio is always the left side. You base on the step before. So the step before is H2SO4. The one on the right side is always based on what you need to solve. Yep, so this one is always based on step 2. This would be always based on what the question is asking. So since the question is asking for carbon dioxide, that's why right side I write carbon dioxide. Then same thing, you look at the number, H2SO4 is 3, carbon dioxide is 3, that's why it's 3:3. That means it would be exactly the same. Then you step 4, answer the question. Since they're asking you to solve for volume, and this gas, you can use this formula, the over 24 formula. Yep, so if you rearrange it, it becomes mole times 24. Next, for mass, you can use the favorite formula, which is the mole equals to mass over mR. Then if you rearrange it, it will be like this. Then you just times the mR, then done. So this would be the answer. Okay? Yep, so this, so with this, we can also fill in the answer into your booklet. Yep, so let's fill it in. So the number of moles of carbon dioxide would be 0.025. Then the volume would be 0.6 and the mass would be 1.1. Yep, like that. So the first row you'll fill in, right? Yep, so just fill in the second row, we'll do then. Okay, so moving on to the next part, next question. So this is question number 3. This time round, I'll add in one more. Besides the step 1 to 4, let's add in limiting and excess also. So now, how do you, okay, so if I were to, for example, right, if I were to erase the part A, so maybe this part I erase it, so if I cover this, and just by looking at the question itself, how do you recognize that it's a limiting and excess question? Because need to recognize. Because sometimes question not so nice. They won't write down like part A, identify the excess. So if they never show you the part A, how do you tell? Mainly is, can you see? Over here, they tell you the value for the first substance. Over here, they also tell you the value of the second substance. So as long as the quantity of both substances given, this means that it is actually an excess limiting question. So can you follow and copy it down? So need to recognize, okay? Especially MCQ. Usually MCQ, they tend not to tell you that it's limiting excess questions. So how do you tell in an MCQ? You look at this. As long as you can find the number of moles of both substances, likely it's because they want you to compare. See who is more and who is less. Yep, so let's write down. This would be a limiting excess type of question. Yep, so follow and copy in. Okay, so now for part A, they are asking you to determine the excess reagent and show your working clearly. So how do you solve it? So likewise, whenever you start doing more question, right, first thing is always think of, can I use the 4 step or not? So even you see, even though at the start, you know it's a limiting excess question, always think of the 4 steps because I told you that 50% of the question can actually use the 4 steps. So now I just try first. So I try step 1. Yep, the question already gave it to me. Write the chemical equation. Step 2, can we find number of moles? Can, right? With mass, you can find number of moles. With concentration and volume, you can also find number of moles. So that means this time around, yes, you can find number of moles. So since you can do this, then likely you can do the 4 steps. So you continue on with mole ratio. So I'll just use like maybe either one. Maybe I use the first one for example. So what you need to do is you look at the equation. Aluminium carbonate is 1, right? Then sulfuric acid is 3. That's why in this case, you based on the ratio 1:3, then you copy this in. Yeah, then by right, if 1:3, if you times 3, this is the value. And with this value, let's check. That means this amount of aluminium carbonate only needs to react with 0.03 sulfuric acid. But now, how much am I given? I'm given, so this is the given amount. I'm given this amount of sulfuric acid. So if I'm given 0.05, but I only need to react 0.03, aren't I being given too much? Yeah, because I should only need 0.03. Then in this case, we can conclude that the sulfuric acid too much, that's why it would be the excess. Then the other person would be the limiting reactant. So you see, even for limiting excess, you still use back the 4 steps. Can? Any questions so far? All good? Okay, then now let's fill in into our booklet again. Yep, so let's fill it in. So based on the information and the calculation steps above, earlier on, yep, so these are the numbers that we calculated in the previous slide. Yep, so can you all fill in the blank? Just because I find that like if I were to teach using the revision kit, a bit no space to write working, cause like not much space. Yeah, that's why I printed out slides so that like you have space to like write your workings in. Okay, so all these values are all from the previous slides that we have calculated just now. Egan, this is notes page 20. But the slides is the slides that I showed at the start of the lesson. So if you were late, then I will need to show you the QR code to scan. Okay, so everyone done copying, right? Okay, so I shall move on. Anyway, if you're not done copying, no worries. You have the slides, right? So the answer is in there lah. Okay, so moving on. So moving on to part B. Okay, so still the same question on the excess limiting, and you can see right there, this part here. So now part B, they are asking you, calculate the number of moles of aluminium sulfate. Okay, so since, as mentioned just now, once you know that it's a limiting excess type of question, you should always follow the limiting percent number of moles. So that's why if you know that we have identified earlier on, right, there, over here, that aluminium carbonate is the limiting reactant, we should use the aluminium carbonate's number of mole. So that means all our question now, our calculation should all be based on 0.0128. Yeah, so that's why over here you see that, you see, we calculate based on 0.0128. And now they are asking you for aluminium sulfate. So that's why you see, on the left side, you always base on the one in the previous step. So in the previous step, this was like part A, right? Then this is usually your question. So that means the left side is always based on the previous part, while the right side is always based on what the question is asking. Question is asking for aluminium sulfate. That's why you write aluminium sulfate in. Then now you look at the equation. Aluminium carbonate is 1. Aluminium sulfate is also 1. You write it in. Then now you copy down the answer from part A. Then it will be the same number. And hence we know that aluminium sulfate, the answer is this. Done. So this will be the answer. Okay, then moving on to part C. Now, they ask you to calculate for someone else instead. So instead of calculating for the aluminium sulfate, now if I were to ask you to calculate for water, what's the number of moles of water? Likewise, you always follow the limiting reagents number of mole. That's why you use back the 0.0128. Then for water, because this is 1:3, that's why this time around you need to times 3 to the value. Yep, so that's why the answer would be 0.038462. Okay, so this is also one of the answer in the revision kit, page 20 lah. Yeah. Okay, I continue on first. Then later I show you one shot, all the answers for the revision kit. Okay, then next, if we were to calculate the next one, how about carbon dioxide? So for carbon dioxide, likewise, always follow the limiting reactants number of mole. Then since this time around carbon dioxide is 3, right? Then just times 3. And next is, besides calculating number of moles, they also want you to calculate volume and mass. then you just use the appropriate formula. So for gas, you can use the 24 formula, right? And then for mass, you use the favorite formula, which is the moles equals to mass over mR. Then you just rearrange it to get the answer. Then done. So this would be how you calculate the volume and mass. Yeah. So after a while, if you know what are the question type that will come up, you can slowly get the hang of it. Yep. Yeah, so these are the answers that we have went through in part B, C, D. So can you all copy down the answer into the revision kit? Okay, should be almost done copying by now. If you're not done, you can just refer to the PowerPoint slides. The answers are in there. Okay, so I shall move on. Okay, so next will be another question. This time around, I'm changing the number. Okay, so this is question number 4 now. So we will now move on to the next question type. So just now we covered question type 1 and 2, which is the 4 steps and the limiting access. Now we move on to question type number 3, which is the percentage. There's 3 of them, right? There's percentage, purity, mass, and U. So let's take a look at how to solve percentage purity type of question. Okay, so for this question, the equation is still the same. But this time round, they say that it's a 300-gram sample containing impure of the first substance was added to this amount of sulfuric acid to produce this amount of carbon dioxide. And they ask you to calculate the percentage purity. So take note that whenever question gives you something that's impure, this value over here, you cannot use it to do any mole calculation. That means like, like you cannot put this 300 gram into like mass over mR. Cannot. Because this contains impurity. That means it not only contains aluminium carbonate, it also contains some other substance. So that means if you take this number to be mass over mR, your mR should not only be aluminium carbonate. Your mR should also include the impurities, but you do not know what's the impurities. That's why this number here, you cannot use it to do any calculation for like calculating like moles or anything. Instead, you just later put it in the denominator of the percentage purity formula. That's all. You can't process this value further. Yeah, you can only put it in the denominator. You cannot go and like divide mR or times anything else. So what you should be using to calculate would be the right side here. Yeah, so use the sulfuric acid and carbon dioxide to do the calculations. So what you can do would be, for this case, it would be for the number of moles of aluminium carbonate, this was actually linked to the previous part. Yeah, so in the previous part, right, let me just scroll to the front. Okay, so for the previous part, let me see, where is it? The number of moles was from earlier on. And is it here? Yeah, over here. So this was the part that I skipped, which is the question 1. So because the question are all like interlinked, that's why it's in the same table in the revision kit. So the number of moles of aluminium carbonate was calculated to be 1 mole. So that's why based on the front part, now they put it over here as 1 mole. So that's why it's mole times mR. Then you get this mass. And then now you use the percentage purity formula. So percentage purity formula, if you look at the notes page 19, yeah, the formula there, they mentioned that it is actually the pure over the total, which is, let me show it to you. So if you refer to page 19, this was a table, right? So take note that because in order for percentages to be overall must be less than 100%, that's why your formula over here, take note, it must always be smaller number over bigger number. Can you write it down in notes page 19? Are you looking at your booklet page 19? Yep, so it's always smaller number over bigger number. So same for the rest. Let's write it in. Because in order for percentage to not exceed 100, you all know, right, from math, must be small over big one. Because if it's big over small, then what happen? Big over small, it will exceed 100%, which is impossible. Yeah, so it's always small over big number. So in exam, if you're confused, ayo, I don't know which one is actual U, which one is theoretical U, no worries. You just look at the two numbers, just put small over big, done. Finish copying, right? I shall move on. Okay, so that's why for this question here, yep, so what you need to do is you have this mass, you also have this mass. Then remember I told you small over big. That's why you take 234 over 300, then times 100%. Done. So this would be the answer. Okay, so let's now fill in this answer into the table also. So can you fill in the answer? It will be 234 grams and 78% for section number 3. Yep, so section 3, the answer is 234 grams and 78%. Yep, like that. Okay, so before I continue on with the slides, there is actually a question in the mock paper that is related to percentage purity. So let's take a look at question number 11 now, with the mock exam paper at the back of the booklet. Okay, so for question number 11, the answer is B. Did you get it correct? Question 11, the answer is B. Okay, so let me now go through it. So for question number 11, which is here, let's take a look at this question and see whether can apply what we have just learned so far. An impure sample of 1 gram of silver oxide reacts with excess nitric acid to form silver nitrate and water. And the reaction produces this. So remember I told you, whenever it's impure, you cannot use this number in any like what mole over mass over ml calculation. Cannot. You can only use this as the denominator of your percentage purity formula. So that means what you should be using to calculate like moles, it should be this value over here. So now using this value, of course, you try to think of the first 4 steps first, right? Can we use the 4 steps? Okay, so let's try. Step 1, it would be chemical equation. So yep, so far possible. Step 2 is number of moles. Let's try whether can we calculate number of moles. So in this case, the number of moles of silver nitrate, which is this, it would be, they give you mass, right? Mass, isn't it the mass over mR formula? And then now you put 0.86 over the mR. So maybe can someone help me to press the calculator and tell me like what's the answer? So in the end, after you press the calculator, what's the number of moles? Anyone? I believe at least some of you did the question, right? The mock exam question. So what's the answer? Has anyone calculated? Yes, Jaylene, thank you. We are right again. 0.0051 5061. 8. Okay, thank you. Yeah, so this would be the number of moles. Okay, so then next would be that now that you get the number of moles, what do you do? So done with step 2, right? You move on to step 3. Okay, so let's give you a try for step 3. Maybe I write over here. So for step 3, it would be the mole ratio. So this time round, remember I told you the left side is always based on what you calculated in the previous part. So previous part is AgNO3. That is to what you need to solve. So in this case, if you are solving for the impure sample is silver oxide. That's why the ratio should be to silver oxide. And now, based on the equation, the silver nitrate is 2. The silver oxide is 1. Then you continue to copy down. This is the left side. Then it's to the right side. So need to halve it. Yeah, so can someone help me to press the calculator? If you halve it, then what's the value? Can say louder a little bit. How much is it? 2530. No more digit behind the back, is it? Okay. I write something wrongly. Is it 25309? Is it? Okay, thank you. Okay, so now that we have the number of moles, then we move on to step 4. So step 4, it would be always answer the question, right? So in this case, since the question is on percentage purity, and remember I told you, percentage purity is always in terms of mass. So that's why step 4, we should calculate the mass of the Ag2O. Yep, so to calculate the mass, you will take the number of moles times mR. Yep, so it would be this number of moles times the MR. So what's the MR? Then you just sub it in and then you calculate. I realize you all don't have periodic table. Okay, I think I distribute the periodic table first. Then you all can use it to calculate. A-level periodic table for science students. Use the O-level periodic table. Your net number is like the whole, that means your mass number, is it a whole number one? Yours is whole number, is it? Oh, okay, can then I shall give another one. Hold on. So how am I not doing the then I shall not use what I anyone else use the O-level periodic table, the whole number one? What's my decimal place? So you all use the whole number. Okay, I'll give you the other. What's the decimal place, right? Okay, let me get the whole number periodic table. Okay, so now that I've given you the periodic table, so how? Can you give me the number now? Let's exchange, right? I give you periodic table, you must give me numbers, right? Yeah, so what's the... So can I have the number? So what's the MR over here? Hello, what's the MR of Ag2O? How much is it? Again, 1.8. Okay, then thank you. So if your periodic table is the whole number one, then I believe your number should be 232 instead lah. Okay, the numbers are pretty close. Okay, so maybe let me address Egan's question. So you are saying that the number of moles of AgNO3 why not divided by 2? Isn't there 2 moles in step 2? Step 2, as in this, wait, I don't quite understand your question. You are saying this number you want to divide by 2, is it? Is that what you're trying to ask, Egan? Okay, okay. So for the number over here, this is for 2 units of AgNO3. That's why if you want to find the Ag2O, it is 1 unit. So from here to here is actually divided by 2. So that means you don't divide by 2 over here because this is just, based on the mole concept formula, it is mass over MR. That's why you just based on, okay, the mass, they give it over here to you. Then the MR is just based on the chemical formula. You check periodic table, right? You count. So that's why you have to follow closely. So once you get this number of mole, this quantity is representing 2 units. So you cannot divide by 2 because it has 2 units. So 2 units is this value. So if you want to calculate for Ag2O, which is 1 unit, you then divide by 2 to get for Ag2O. So then you are saying to find MR, don't you need to use mole ratio? Don't need. MR is just look at the chemical formula, ignoring the number in front. So MR is just AgNO3. That's MR. So MR is the mass of the compound, excluding the coefficient in front. Okay? Okay, so then next, have you pressed the calculator? What's the value for this? What's the value here? Have you pressed the calculator? Oh, you want the O-level one? Oh, okay. Why don't your school use the decimal place number? You also use the whole number. Oh, okay. How your class never tell me when I give the decimal place one? Okay. Okay, but anyways, what's the value over here? What's the value? Hello, people, have you pressed the calculator? Quick, people, you know that I only have 3 hours with you all, right? If you can't wait and wait and wait and wait, then what happens behind? I will just cut off the behind topics, and then isn't it a disadvantage for you? Okay, so let's try to cover as much as we can during the lesson. So what's the value over here? Oh, thank you, Shahana. 58666. Same, right? The rest of you got the same number, right? Can I? Okay. So then in this case, once you get this value, then now you can use the percentage purity formula. So percentage purity is always small mass over big mass. Because remember, we need to get it less than 100%. That's why it should be 0.58666 over the bigger mass, which is 1, then times 100%. Yep, so that's why once you press calculator, I think you can tell, right? Like you times 100, you shift by 2 decimal place, it should be 58.7. So answer will be B. Hi, yes. Do you need some help? Oh, the revision kit. Oh, okay, okay. Sorry, those online, give me a while. So let's continue on to the slides. Yeah. So moving on, done copying, right? Okay, so back to the slides over here. Yeah, so that's how you apply on using the percentage purity formula. Okay, so let's move on to the next question over here, question 5 of my PowerPoint slides. Okay, so next they said that same equations to you, but this time around I changed the numbers a little bit. And I'm asking you to calculate the percentage yield. So same thing, this time round, given these two values, so how do you go about solving it? Okay, so since the concept is still the same, as long as it's percentage, you just need to remember your formula is always small over big number. So for this question, since the style is the same, I'll leave it to you to give it a try. Then after you're done trying out at home on your own, you can just refer to the next slide for the answer. So you see, it's like what I went through already, the step 1 to 4, and then later just take small over big number times 100%. Okay, so you give it a try on your own at your own time. Then after that, you fill in the answer into the revision kit. Okay, then I shall move on. So the next type, so done with, so purity I demonstrated to you. You, just like I told you to try it out on your own at home. So now I move on to the third one, which is percentage by mass. Okay, so over here, percentage by mass, how do you solve it? Is mainly by, they will usually ask you which atom they are interested in. So for example, like if it's calcium carbonate, if I am interested in maybe like what's the percentage by mass of calcium, what you need to do is you go and check the periodic table for the MR of calcium. Yep. So by the way, this is actually found on in the booklet, page 19. Okay. So your booklet, page 19. So for percentage by mass, what you need to do is you put the MR of calcium divide by the total MR, then times 100%. Because as mentioned before, it's always small number over big number. So this is trying to say that, like, you know, if my whole substance is like this amount of mass, like 100, so how much is actually the mass of calcium? So I want to find out like the percentage, the fraction of it. Yeah, so that's why it would be the MR of the one that you're interested over total. Then we know that, okay, so among the whole calcium carbonate, 40% of the mass is actually contributed by calcium. So likewise for the next one also, just put the MR of carbon, MR of oxygen over total, then times 100%. Yeah, so this will be how you calculate. Okay, so then I shall move on. Yes?
Do you know like how much of the elements that contain inside the, like for example, there's 20 grams of calcium.
Oh, okay. So for this part over here, they base on the MR because in for MR is also known as the molar mass. That means in 1 mole, it would be 100 gram, because if you use the favorite formula, which is the number of moles is equals to mass over mR. If your mR is 100, then if your mole will be based on molar, molar means like 1 mole, which is 1, then do you realize that your mass would be 100? That's why your mass, which is in gram, happen to be 100 gram. So that's why out of the 100 gram, then how many is each of them? So this time around, they went to do half of it lah. Yeah, but if you do as 100 gram, then it would become 40 gram of calcium, then 12 gram of carbon, and so on. Okay, so moving on to the mock exam paper, let's take a look at how do we apply such percentage by mass kind of question. FRQ means free response question number 3. So can you flip to your mock exam paper, free response question number 3. Okay, so this is the answer. Yep, the answer is 11.8%. You managed to get it correct? Okay, so how to solve for this question? So they said that the reaction is as shown. 3 tons is million, that means 3 million grams of hydrogen were reacted in the reaction to produce 2 million grams of ammonia. And you're supposed to calculate the percentage yield. Okay, so what I need to do is, since they have given you this amount of hydrogen, of course, you will try to see whether can you use the 4 steps or not, right? So that's why step 1, it would be, you try calculate number of moles first. So yep, you can calculate number of moles, right? By taking mass over mR. By the way, don't need to like very busily copy down the correction, because later I'll give you the answer key also. Yeah, so I would rather like, you focus and listen to my explanation. Then if I write any notes, you write down the notes instead, because the answer key will just be the red color working. Yeah, whatever that is in blue, it won't be in the answer key. Yeah, so why not you listen to my explanation and write down my annotation instead, because all this not in the answer key. Okay, so first you take a mass over mR. Yep, so that's why the mass is like 3 million over the mR of hydrogen, which is 2. Then that's the number of moles. Then once you're done with this, okay, or rather this is step 2, right? Because step 1 is always chemical equation. So step 2, the first step you calculate is always calculate number of moles. Then step 3, you do the mole ratio. Yep, so in this case, what's the number of moles? So the left side is always based on what you have calculated in the previous step, which is H2. Then the right side, it would be what you want to solve. So what you want to solve is the percentage U. So U is like the mass of the product. Can you write it down? Like for example, like if you say the farmer grow crops, then what's his U? So U is the end product, like maybe like the crops that he managed to grow out. Yep, so U is the product, not reactant. So this time around, what's the product? It would be NH3. Then now you look at the equation. Hydrogen in front, number 3. NH3 in front is number 2. Then you fill it in. So H2 is it's 1.5 million. So that's why you just count accordingly. So if 3 units is 1.5 million, 2 unit would be 1 million. So this would be the number of moles. Then it's done with step 3D. Then you move on to step 4. So in this case, since we mentioned, right, that whenever it's percentage, you must always calculate in terms of mass. Yeah, so remember, percentage is always in terms of mass. Yep, so that's why you go and calculate the mass first. Given number of moles, you can calculate mass, right? Because mole times mR, you can get the mass. And that's why you get this value over here. And now you answer the question exactly, your percentage U. So remember, if you have 2 mass, like 17 tons versus over here, the 2 tons. Yep. So it's always small number over big number. So you see, even if you don't know which one is like whichever number to put, you just take small over big. Small over big, then it would be this answer. Done. Did the rest of you get 11.8 or 11.9? Those of you who calculated, what did you get? Because someone online mentioned that they got 11.9 instead. 11.8, right? Then it should be 11.8 lah. Yep, like that. Can? Okay then, so I shall move on. No worries, if you're not done copying, I will still give you the answer key so you can slowly copy down the correction at home at your own time. Let me answer the question from those online. So Porcupine is asking, isn't molar mass the bigger number, so 40 for calcium? Oh, that's for the previous question, is it? Okay, let me go back to the slides. Okay, so I shall close the slide then. Sorry, I closed the mock exam. Okay, so let's come back to here. So about the number 40 for calcium. 40. Are you referring to the right side here for Porcupine's question? What are you trying to ask? I'm not very sure. What are you asking? On the left side, okay. On the left side, 40. Where is the 40? This one? Or this one? Which one are you referring to? Oh, why 20 over 50? Oh, okay, okay. Because okay, you can just look at the right side lah. I would think that is easier. Yep, so it's just because total mass is 100, so calcium it is 40. That's why 40 over 100. Over here is because the question they went to half the mass. So instead of giving you 100 gram, they go and do 50 gram. That's why for calcium, which is 40, they also halved it, so it becomes 20. Yeah, so that's why it would be everything is half. I think you look at the right side is easier to understand lah. The left side is because they went to change it to everything half the value. Okay. For Tan Fuki, you're asking what is MR? MR is the mass number in the periodic table. So if you check periodic table, the bottom number, that is the MR value, the mass number. Okay, so moving on. So next question over here, question 7. So if you follow my slide, it will be question 7, okay, for the slides. So this is the next type of question, volume ratio. If you know how to use this, right, you can save a lot of time. Yep, so you might see that, okay, you see that there's volume, then you might think of, okay, volume is like the over 24 formula, right? But actually for this question, you don't really need to keep using the over 24. Why? Because once you have volume ratio, you can actually do the shortcuts. Okay, so let's take a look at this question. They have this chemical equation and they mention that there is this mass. Then you're supposed to calculate the mass and volume of hydrogen that is required to react completely. Okay, so in this case, if you want to calculate, first thing is we must always think of, can we use the 4 steps, right? So let's check. So we have step 1 over here, which is the chemical equation. Let's try to do step 2 now. So can you all follow and copy it down? Because there's no working behind. Yeah, copy it down. So step 2 would be, you try to calculate the number of moles. So in this case, are we able to calculate number of moles? Can, right? You have nitrogen over here. So let's calculate the number of moles of nitrogen, which is mass over mR. So if you check periodic table, nitrogen is 14. That's why mental sum answer is 1 mole. So done with step 2. Moving on to step 3, which is the mole ratio. So for mole ratio, you always take number of moles of the previous part, which is nitrogen, then is to number of moles of the next part. So for the next part, what are we calculating? We are calculating for hydrogen. So that's why I will put in hydrogen. Then now I look at the equation. For nitrogen, in front don't have number, means 1. Hydrogen, H2, in front is 3. So I put in number 3. Then now I transfer it down. So N2 is 1. That means 1 is to 3. And so this is, I just, oops, over here. Okay. So first row is always based on the chemical equation. Second row is always based on what you have calculated, the actual number of moles. So sometimes it can be in decimal place. Okay, then done with step 3, then we move on to step 4. So we are supposed to calculate the mass. Okay, so let's calculate the mass. So do you all know what's the formula for mass and volume? Why not you give it a try? I already got you for the first 3 steps. Can you finish up the last step on your own? What is the mass and volume? Okay, so this part over here is because of the formula mass over mR. So for the mass, this is the mass, right? Mass is always in gram. mR is the bottom number in the periodic table. Yep, so if you check periodic table, you have a periodic table with you, right? And then you look at the periodic table, you find letter N, nitrogen. The bottom number is 14. And then since there's 2 nitrogen, that's why I need to times 2. Okay, so in the end, what answer do you all get for the mass? So what's the mass of hydrogen? What do you all get? Correct, 6 gram. What's the volume that you all got? 72 dm cube. Wait, let me just double check. Volume, number of moles times 24. Ah, yeah, correct. Okay, so then next would be everyone done, right? Can get the answer, right? Don't need me to explain, right? Okay, then move on. Okay, so moving on to the next part, part B. Calculate the mass and volume of NH3. So this time round, likewise also, can you all give it a try? It's the same few steps again, similar to part A. So if you know how to do part A, it is the same for part B. Can you give it a try now? Show you the working for part A. Yep, you can take it as a reference. So this time round, you can do N2 is to NH3 instead. So the working is similar. You just need to change this to become NH3. Then you change the circled ones accordingly. Oh, yep, so this would be the answer. Do you manage to get the same answer also? Can? So the answer is 34 gram and 48 dm3. And the working is the same lah. So you just, is everything the same? Just need to change the circle parts accordingly, like the way that we did. Then can video. So okay, right? I shall move on. Okay, so done copying, right? Because this one is not in my side. So this one you must really copy it down, because I didn't provide the answer. Okay, right? I move on in 3 seconds. If you're not done, you take a screenshot. 3, 2, 1. Okay, moving on. Okay, so yep, then in that case, you can fill in the blank one, the 34 and like the 48. Yep, so that we calculated. Yep, so can you fill in the blanks now? So all these we have calculated in the previous 2 slides. Okay, so for this part over here, we didn't really calculate. So this part, let me just explain to you what is this about. So this is actually about the volume ratio, meaning volume ratio, you can actually use a shortcut, which is you can go by the units to know the volume. That means don't need to use the what? Over 24 method. So for example, if I give you 90 cm cube for hydrogen, this is trying to say that 3 units is 90 cm cube. So in this case, if you are supposed to calculate for nitrogen, can you see that it's 1 unit? Then just do your simple math lor. If 3 unit is 90, 1 unit isn't it 30? So that's how you get the number 30. Then next for NH3, NH3 is 2 units. Then you just do accordingly again. 1 unit is 30, 2 units isn't it 60? Then that's how you get the number 60. So this is what I meant by the volume ratio. So that means volume ratio, you can go by this kind of proportion method. Just how many units is how much cm cube. There is no need to use any formula like what over 24 kind of formula. Don't need. For Joanne, right now this is my slides. So this was the slides that I showed at the start of the lesson. So could it be that because you came online late, then you didn't manage to get my slides? Because I showed the QR code at the start of the lesson. So right now, my slides is actually just a modification of the revision kit, page 20. Yes means what? I don't quite understand. I say a lot of things. I don't quite know which yes are you referring to. Like which part of my question? Okay, so everyone done copying, right? Okay, so I shall move on. Okay, so oh, you came late. Okay, I quickly show you. Can you quickly scan it? Then I can move on. Yep, so it's the right side. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, then Egan is asking about the 48. Okay, let me go over there. Where's the 48? Over here. Oh, 48 was my working just now. Oh no, can I undo all the way? Let me check. If you copied just now, you should have the 48. There, over here. There, just now we calculated the mass and the volume. So that was how we fill in the 34 and 48 into the blanks in the revision kit. Okay? Okay, so I shall move on. Okay, then the next part over here, mixed question type. So this time round, we'll mix in both the limiting and excess plus volume ratio. So since I already went through these two types of question, I believe you should know how to do it. So can you give it a try on your own? Yep. So then after you try it out, then the next page have all the answers to it lah. Okay, so you give it a try but on your own to see whether can you get the answer. So let's now take a look at instead of trying the notes, we directly look at the actual question in the mock exam paper. MCQ question number 10. Can you all stick to your mock exam question number 10? Over here. Okay, so for question number 10, the answer is B for boy. Okay, so how to get the answer B? Let me demo it to you. Okay, so they said that they have this reaction. What's the total volume of gas left in the mixture when 150 cm cube of hydrogen reacts with 150 cm cube of oxygen? And again, do you see that? You have two quantities. So as long as two quantities are given, remember I told you, it would be limiting excess question. Do you notice the whole question never use the word limiting? The whole question never use the word excess. But you need to recognize that this is a limiting excess type of question. Yeah, so that's why I said need to recognize the question type. Yep, so can you write it in? This is a limiting excess type of question. Okay, then now let's calculate. So you can use either one of them to calculate. You want to use hydrogen also can, you want to use oxygen also can, doesn't really matter. So maybe I just use the first one, for example, hydrogen. So for hydrogen, it is, since all of them, these two are gas, you can actually do the volume ratio. So remember I told you, as long as gases, you can use volume ratio. Take note, volume ratio is only for gases, which we have written on the very first page, right? Remember the 7 question type? We wrote that volume ratio, you put bracket gases. Yeah, so this is for gases. Come, let's do it now. So this is 2 units. So 2 units is 150 cm. So then in this case for oxygen, it is 1 unit. So 1 unit, it would be, you have it, 75 cm cube. So that means the amount of oxygen that has reacted is 75 cm cube. But how much oxygen was I given? I'm given 150 cm cube of oxygen. Aren't I being given too much? But this is what's given, ma. But I only need to react 75. Then now we know that oxygen would be the excess because I'm given too much. Then hydrogen, it would be the limiting. Then remember I told you, whenever you want to do any calculation, whose number should we follow? Should we follow the limiting or should we follow the excess? Whose value should we follow? Whose value should we follow? The limiting. Yep. So that's why now all the calculation you base on the limiting. So don't use the 150, okay? Okay, so now let's calculate. What's the total volume of gas left in the mixture? So the amount that's left, it would be the excess, right? Okay, so this time round, 150 minus 75, you left with 75 lor. Oh, this is an easy question actually. Yeah, because usually once you found the limiting, usually you need to go and calculate using the limiting's value. This time around, don't even need to do that. Just need to find out how much left over will do. Okay, then done long, that's all. You copied the corrections, right? Because take note, the answer key that I give you for the MCQ only got A, B, C, D. Don't have the working. Yeah, so you need to copy down the working. Okay, so Yes. This time around don't need because the product is not a gas. This time around they only asking for gas, so it's only the reactant. Yeah, it's true lah that if they were to ask you like total volume of gas left, if your product is a gas, then you need to include the product also. But happen that this product is not a gas, that's why don't need to include the product. Okay, so I shall move on back to the slides. Okay, so continue on. Next would be yeah, so all this you give it a try on your own, then the answer is shown here. Okay, next question type. So we're done with question type 1, 2, 3, 4. Moving on to type number 5, it would be the empirical and molecular formula, which you need to use the table. Likewise for quarter of crystallization, so the like copper sulfate dot XH2O kind. So since both of them use the table, I will teach them together. So mainly this part here, minimally you must at least memorize that. The first row is always, you can, okay, usually the way I write is, I'll just write as mass or percentage. So you look at the question. If the question give you in gram, you write mass. If the question give you in percentage, you write percentage. Then the next row, you write down AR, then number of moles, then ratio. Don't need the mole ratio, just mole, just ratio will do lah. Yeah, so need to memorize for each row. Then for each row, how do you derive the answer? So for the first row, usually you derive it from the question. The question will provide it to you. Then take note, okay, if it's in percentage, make sure that total all three of them should add up to 100%. Because sometimes question might just give you the first two. They never tell you the third one. So the third one is just based on 100%. You minus the first two, you can get the last one. Okay, then the second row, you check periodic table, the bottom number. How that's the MR or AR. So check periodic table, bottom number. Then the third row over here, moles, isn't this our favorite formula? Because moles is equals to mass over MR, right? Mass is the first row. MR is the second row. That's why to get the third row, you just take the first row value, divide by second row. You do accordingly. So the first column is first row divided by second row. Same for the second column. First row divide second row. First one divide by second one. Then equals, that would be the answer in the third row. Then once you have the answer in the third row, how to derive the answer in the fourth row? You go and find the third row, whose digit is the smallest. So once you found the smallest digit, you just need to divide by smallest digit in third row. Divide by smallest digit in the third row. Yep, then this would be how you get the answer lor. Done. Then take note, okay, for your mole ratio over here, if your number is like, for example, 1.5, right? 5 is right in the middle, you don't go and round up. If it's 1.5, you should times 2. Okay, so take note that as long as there is a 0.5, like maybe 0.5 or 1.5, make sure that you times 2. So for mole ratio values, if it's 0.5, you must go and times 2 lah. How do I write? Yep. So that means, example, if your answer is like 0.5, 1.5, and 2, something like that. So you just make sure you times 2 to all of them. Don't go and round off. Don't go and round off to become 1, 2, 2. 1, 2, 2 is wrong. So that means the correct answer should be 1, 3, 4 instead. Clear? And another kind of mole ratio, right, that you shouldn't round off is this kind. Like if they give you as 3.3, 6.6, and 3.3, like the 3 rows. 3.3, 6.6, and 3.3. You know, obviously this is double, right? So you don't go and round down the 3 and round up the 6. So that means your answer shouldn't be 373. This is wrong. The correct answer is, it should become 1, 2, 1. Because you know 6 is double of 3 ma. Yeah, so that's why, like, how to say, like the mole ratio is not like, oh, always follow mem, or a 0.5 and above always round up, 0.4 and below always round down. You must look at the scenario. Yeah, so cause some scenario is that you're not supposed to round off. Yeah, like over here, you see, you are supposed to like divide. Yeah, so just take note. Okay, so this will be how you solve for empirical formula. Okay, so this table here is for empirical formula. So yeah, I'm done for the first one, empirical formula. So if happen that all of them are 0.3, example like all of them are 0.33, 0.33, 0.33, then it's all the same, and then it's 1, 1, 1, no. Is that what you're trying to ask? Okay, then next part over here will be molecular formula. So how do you do molecular formula? The rule is you have to convert all the alphabets into numbers. Okay, so let me write it down. So for molecular formula, you convert all like atoms, which is all the alphabets, into number. So what is the so-called number? The number would be your MR. Then after that, you then add the letter N. So what do I mean by that? So for example, maybe you have the formula here. Maybe your formula is like CH2O, for example. So if you have CH2O, how do you do molecular formula? You will go by the carbon. You have to change this alphabet into the number. So you check periodic table. What's the mass for carbon? Mass of carbon is 12, correct? But I need to add in letter N. Then plus the next one, hydrogen. You check periodic table, is number 1. Then add in, there's 2 hydrogen, right? So you must times 2 and add in letter N. Then for oxygen, you check periodic table. What's the alphabet? Oxygen O, right? You check the MR is 16. Then add in letter N. Then this whole thing, you let it to be equal to the mass number. So usually the question will tell you like, what's the mass? Then you, maybe if the question this time around tell you that, okay, the mass is like 180. Then what you do is, you just let it to be 180 lor. Then you solve for the letter N. Then after that, you do the math. If I'm not wrong, it should be 6 lah. Yep, so that's why in the end, your molecular formula would be, you just everything times 6 lor. So it would be C6H12O6. Yeah, so this would be the answer. Okay, then moving on to water crystallization. Okay, this one I think is a bit newer to you all, because by right, empirical and molecular formula, all these things that I teach you all, by right, you all should know it, right? Because all this already taught in school before. Just a recap. Okay, so now that I've done recapping, let's use what you have learned in empirical formula to do for water of crystallization. So that means it would be, okay, so settled for molecular. So water of crystallization question, usually the one they like to ask is copper sulfate dot X H2O. So usually the question will give you this formula and they ask you solve for X. So whenever you see such question, right, solve for X over here for the water of crystallization, what you do is you draw back the same table, okay, like the empirical formula table. What you need to do is the left side, you put in your compound. So maybe my left side, if it's copper sulfate, I'll put copper sulfate, and then right side, I put water. So it's a bit different. You know, earlier on, we only put one atom. Like you see, earlier on, maybe I just put maybe C, and then H, and then O. I only put in one alphabet. But for water of crystallization, you have to put in the entire compound. Yeah, so you have to put in the entire copper sulfate, entire water. Then usually question, so you need to find the mass, right? This kind of question, right? Usually the way they phrase is, okay, originally, what's my mass? And after I hit it for a while, they'll tell you, what's the mass now? So after you hit it for a while, usually the mass will be lower. So how do you find the mass of water? Usually is based on the difference in mass. So usually this one here, right, the mass, it will be the mass, yeah, this one will be the difference in the mass before versus after heating. No space, okay, like that. Yep, so can you copy it down? So for the first row, for the mass of water, the mass of water is always the difference in the mass before and after. Because you need to know that before, you got water. If you heat until like evaporation to dryness, isn't it no more water? That's why the mass after you heat, it will be only copper sulfate. Let me maybe write it clearer. So before heating is usually CuSO4XH2O. But if it's after heating, right? After heating, the water will be gone. That means after heating, it will be only CuSO4. That's why for the first row, which is the mass, what is the mass of water? Do you realize you minus this two? When you minus, isn't it the mass of water? That's why this box over here, for the mass of water, usually the question will tell you before heating how much, after heating how much the mass, you just go and minus. That will be the mass of water. This part can understand? Okay, right? Okay, then for the left side over here, what's the mass of CuSO4? It would be after heating, because after heating, no more water already. Yep, so then let's write down here. Here it would be the mass after heating. Yeah, because mass after heating, it will be only copper sulfate. Yep, like that. Then then after that just fill in as per usual law, which is mass, then the MR. So the MR you need to calculate the entire CuSO4. Then the MR for water you have to calculate the entire H2O, which is 18. Then just continue press calculator lah. So maybe the X over here, if you end up as 5, then you become CuSO4.5 H2O, because the value here is for how much water you have. Okay? So this is how you calculate for water of crystallization. Okay, come, let's take a look at how do we use the table. Let's take a look at the MCQ question number 12. Done copying, right? If you're not done, maybe you want to take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for question number 12, the answer is C. Answer is C. Okay, so for this question over here, you just need to draw out the table. Okay, so maybe let me draw out the table to demonstrate to you. Okay, so first you need to have as per usual, you just follow the table, which is either mass or percentage, right? So in this case, it's percentage, then MR, then mole, then ratio. Yeah, or AR also can. Okay, so for percentage for carbon is 28.6. For hydrogen, it is 4.8. Then for nitrogen is 66.6. Yeah, so that's percentage. MR, just check periodic table, right? So just follow the instruction. Also, first step is always copy from question. Second step, you check periodic table. Third step, you always take the first row, divide by second row. Yep, so can you press the calculator? Then after that, you take first row, divide second row. The ratio, it would be you take the third row, divide by the smallest value in third row. One to two. Okay, so in the end, your answer should be 1 to 2 lah. So after you get the value of 1 to 2, then next is, this is only empirical, okay? So this working over here is for empirical formula. But the question is not asking for empirical. The question is asking for molecular. Then remember molecular, I told you, you must make all the alphabets to become numbers. Okay, so now I move on to the molecular step. So for the molecular formula, you let all the alphabet to become number. So this time around, I have C. C is 12 times 1. Then add in letter N. Hydrogen, if you check periodic table, is 1 times 2. Add in letter N. Nitrogen, check periodic table, is 14. You can see over here also. 14. Then you add times 2. You add in letter N. Then all this must equal to 1, 2, 6. Then you just solve for N law. After you have solved for N, by right, the answer should be 2. That means you need 2 times 2 to all the values here. So it means instead of C1, it becomes C2. Sorry, it should be 3, is it? That's 3. So C1 becomes C3. H2 becomes H6. So everything just times 3, times 3, times 3 lor. And then you can get the answer of C. Done. So this will be how you solve it. Can? All good? For online attendee A, for you are asking a question on the 0.333, right? You have to see the other values. So you cannot just base on only one person's value. Yeah, so if you see, if the rest are all like maybe if this one is 0.33, then the rest are all very nice whole numbers, then you have to round up and round down accordingly. But if all of them are just not like one is 3.3 and one is 6.6, then that one is obviously a double, then you times 2 instead. Yeah, so you have to see the neighboring numbers. Cannot just see the standalone value for question by A. Okay, so then done. Let's move on to the next part. I'm moving on in 3 seconds. If you're not done, you take a screenshot. 3, 2, 1. Okay, moving on. Okay, so the next part would be question type 7. Okay, so you need to know that for such question, right, is that when you are, okay, let me just use a general example, okay, before we use the revision kit. So if you are given 0.5 moles of H3PO4, need to know the difference. Can you see that there's a difference in the question? Here is the number of moles of H plus versus number of H plus. Do you see that there's a difference? This one got extra the word moles. This one don't have. What's the difference? Okay, so if it's number of moles of H plus, what you need to do is, because you should know that acids always dissociate in water to form H plus ions, correct? So for phosphoric acid, this would be how they dissociate. Do you agree? There are 3 H and there is 1 phosphate. So that's why in this case of number of moles of H plus, you have to, first step is, you must always copy down the number of moles given in the question. So you see, you must always copy this 0.5 first. Yep, then like over here also, you're going to calculate number of moles. Yeah, so whenever calculate number of moles, you always first copy down the number of moles you see from the question. Then you multiply by how many ions you see. That means 1 H3PO4 can break into 3 more. Do you realize when 1 H3PO4 you break into 3, that means the number of moles became 3 moles. Because mole is something like, maybe your skin got maybe a mole, something like that, right? The black dot. Yeah, so if 1 dot split into 3 dots, isn't it 3 dots? Yeah, so that's why it will become 3 times. That's why it will be 0.5 times 3 to get 1.5 moles. Likewise for oxygen also. So over here, can you see that there are 4 oxygen atoms? That means 1 H3PO4 molecule, you can break into 4 oxygen out. That's why you need to times 4. So that's how you solve for number of moles of particles. As compared to number of particle itself, because remember I told you on the first slide that you need to specify what type of particle it is. So this time around the particle is ion. If they ask for number of ion, remember the Avogadro's formula? So Avogadro's formula is number of particles equals to number of moles times the Avogadro's constant. Okay, so again, same thing. If your depends, okay, so most IP school, they use the exact number, 6.02. If your school follow the O-level syllabus instead, it will be only 6 lah, without the 2 decimal place behind. Okay, so in this case, take note, okay, this number of moles follow the type of particle in front. That means if your number of particles is in terms of ions, and how many moles of ions do I have? My ions is 1.5 mole, right? That's why you see, the number of moles would be 1.5 moles. Because the number of moles follow the particles. So take note, the number of moles do not follow your compound. That's wrong. Because the number of moles here refers to the number of moles of particle, not number of moles of the compound. Okay, so don't take 0.5. Because this is one of the very common mistake among students. A lot of students see, oh, here write 0.5. Okay, I write 0.5 times Avogadro's constant, which is wrong. Because the number of moles here is the number of moles of your particle. Here, so in this case, my particle, I calculated the number of moles is 1.5. That's why you should put 1.5. Don't put 0.5. Clear? This is a very common mistake. So take note. Okay, then likewise, if you want to calculate number of moles of oxygen, same thing, you copy down the 0.5 times 4. The same thing here, if you want to calculate the number of particles, right? Because remember, I told you particles can be in 3 forms. Can be in the form of atom, molecules, or ions. Yep, so in this case, the number of particles, it would be number of moles times the Avogadro's constant. So in this case, the number of moles, again, follow the particle. If you're calculating atom, it should be the number of moles of atom. That's why number of moles of atom is 2. So that's why you should use 2, not 0.5. Okay, so over here is not 0.5. Yeah, because a lot of students tend to do it wrongly. Yeah, so always based on number of moles of the particle. Yep, then likewise also over here, if they ask number of moles of ions, moles is just mole ratio, right? Because remember, mole is always mole ratio. So 1 can form how many ions? Can form 4. That's why same thing, you always first step, copy down the number of moles from the question first. So you copy down 0.5. Then you have 4 of them, right? You times 4. Then you get the answer of 2 more. Then likewise, if to calculate the number of ions, which is the number of particles, same thing, is number of moles of the particles. So that's why it's 2, not 0.5. Okay, so it's 2 times the Avogadro's constant. Done. Done with the annotations? Okay, so I shall move on. If you're not done, then maybe you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, then the next part over here comes, let's take a look at how can we apply it. Okay, so this is actually your inside your booklet, the next page, page 22. Yeah, so can you flip to your booklet? This is on page 22 of your booklet. Also in my slides. Yep, I have it both sides. Okay, so let's fill in the blanks over here. For the first part here, what's the molar mass? Molar mass means like the mol. So what's the mol of HCl? So you check periodic table. So what's the answer? So H plus Cl, how much is it? H plus Cl, how much is it? Hello, I give you all the periodic table, right? Can you use it? So nice, right? The periodic table and laminated some more. 36.5. Yep. So then now let's answer the question. So same concept still is about the number of moles of particles versus number of particles. Still the same concept. Okay. So for example, if my question give you 5 moles, so I give you 5 moles of the HCl. Okay, so it's just in general. It's similar to like, just now I write like that. 5 moles of HCl. Okay, so in this case, we find more HCl. How to find mass? This one I think you all should know, right? So mass is mole times mR. So just take 5 times 36.5. And how much do you get? How much do you get? Hello, people. What's the answer? Are you pressing your calculator? Again, one what?
182.5.
Okay, thank you. So it's 182.5. Can just times the mR, which is 5 times 36.5. Okay, 5 times 36.5. Okay, then done with this, then next, the third row, it would be how many molecules. So you see, because HCl exists as molecules. So if you look at the number of particles, the particles will be in molecules form. Okay, so this is the original form. So what you need to do is, number of molecules means that it would be the number of moles of the molecules also, then times the Avogadro's constant. Okay, so then this time round, what's the number of moles of the molecule? It's 5, right? Then just take 5 times 6.02. Then in the end, you will get the answer of 3.01 times 10 to the power of 24, right? Am I correct? Should be correct, right? Okay, then next would be the number of particles in terms of atoms. So remember, to look at atoms, you must always see how HCl dissociate, right? So HCl, they can dissociate into one H and one Cl. That's why if it's only one, you just times one. That means the answer is exactly the same. Yeah, because it's just times one. Because it dissociate into one H and one Cl. And then if in terms of ion, it's also one H plus and one Cl minus, right? That's why it would be the same number. So far can follow? Okay, then next would be to calculate the volume over here. So how to calculate volume? In this case, because here is they give you as 250 cm cube. Yep. So then from cm cube, you just convert to dm cube. So cm cube to dm cube is how much? Yeah, 0.25. But hold on. In this case, wait, my answer is 120 dm cube in my answer. Hold on, let me think. Why did they derive this? 120 dm cube. Oh, I think it's because of this part here. Yeah, because this one is for this mass. So for this mass, if you are given, yeah, so you have to prorate accordingly. Yeah, because this one is a different mass. So this is for this mass. So this is the volume. For this mass, this is the other volume. Yeah, because after all, from volume, because this is gases, gas, remember, gas, you can use the 24 formula. Yeah, so that's why you take mole times 24. So you take the mole times 24. So 5 times 24, you get 120. Yeah, so it's different thing. Because this one is aqueous solution, so cannot just convert to the left side. Okay, then next part, it would be to calculate concentration. Concentration is mole over volume, right? So that's why you just take the mole from earlier on, divide by the volume, then you will get the answer of 20. Can? Over here, there. Mole over volume. So I write down working 5 divide by the volume. Volume will be 0.25 because need to convert to dm cube. Yep, then you should get 20. Then moving on to the next part here, from mole, you want to become mass. That means you use this formula, right? Mole times mR, you can get mass. So the mole is 20. Your mR is 36.5 as shown on top over here. Yep, so that's why in the end, you will get the answer of 730. Yep, so over here, they are just trying to show you, see, all the values are actually all interlinked with each other. Can you see a lot of arrows? Yeah, so actually from one quantity, you can derive many other values. Yep, done. Okay, so I shall move on. If you're not done, can you take a screenshot? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. So over here, I've done one example for you here, which is HCl. Can you go home and give it a try to do for the other one, which is the H2SO4. So H2SO4 will be a bit more complex like the H3PO4 because you can break into many H and much more ions. Compared to HCl, it's only one H and one Cl. Yeah, so this one, you give it a try, okay? I already given you all the hints. Up to you. If you feel that you are stronger in mole concept, if you don't need hints, you just directly do the booklet because the booklet don't have any hints. But if you find that like you are struggling, you're not sure, you can refer to the slides for the hints. Then the answer is actually on the next slide. I think so this one you give it a try on your own. So let's now go through the mock exam paper question number 13, which is related to this concept over here. Okay, so for question number 13, question number 13, I haven't go through, right? Yeah, okay, so the answer will be B. Answer is B. Okay, so how do you get the answer for this? Okay, so over here, they said that you have this amount of hydrochloric acid mixed with another volume and concentration, but also hydrochloric acid. So you see, both are hydrochloric acid, you mix together. So what is the concentration? So what's the formula for concentration? If you look at the unit, you can tell, right? So what's the formula for concentration? If you're not sure, you can refer to the first page of the notes for today for more concept. What's the formula for concentration? You look at the unit, you can tell already. Can I have an answer? What's the formula for concentration? Yes, thank you. Yeah, it's mole over volume. Yeah, because you can see, right, then mole and then dm cube, mole divided by volume. So now you need to look in terms of total mole and total volume. So maybe first step, can you go and calculate what's the number of mole first over here? Then over here also you go and calculate number of moles. So after you calculate the number of moles for both of them, you write it into the numerator, the 2 moles. After you calculated the moles for both of them, then divide by total volume. So everything must be in terms of total, okay? So it's total mole, total volume. Yep, so for total volume, you add up, it would be 250 plus 350, that is 600 cm cube. Then remember to convert to the SI unit. Yeah, so for chemistry, volume is in dm cube. Yeah, so convert this to dm cube. So this would be 0.6. Yeah, then just press the calculator. By right, the answer should meet B. You get the answer? Okay, so the next question that I will be going through, I'll just go through all the more questions from this mock paper first lah. So can get the answer, right? Okay, so I shall move on. If you're not done copying, you quickly take a screenshot because I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so the next question that I want to go through is like the question number 3, open-ended. The top part I went through, right? Did I? I went through. Okay, let's take a look at the bottom part. Let me zoom in. Yeah, or maybe if you just go through everything, since like I already go through A, then I'm going through C, may so I just go through B also. Okay, so for B over here, they're asking you to write the dissociation equation with state symbol for aqueous ammonia. So based on the instruction above, they mentioned that ammonia dissolve in water. That's why just plus water, no? And then for ammonia, you can do it as a usual state, which is usually is gaseous state, or that they say like form aqueous ammonia. So you want to write aqueous also can, I accept both. Yeah, then take note, okay, that they mention my state symbol. So do you include a state symbol? And dissociation equation must always be reversible arrow for such weak alkali. Because remember, for strong, it's always solid arrow. Weak is always reversible arrow. So take note, okay, weak is reversible. You want can also highlight it to remind yourself. Now, weak is always reversible arrow. And then you all know, right, since it's an alkali, alkali must form what kind of ions? Alkali confirm form OH minus ion. That's why the answer is OH minus. So if you remove OH, that means you will be left with ammonium ion. Done. So this is how you derive the answer. So you use clues in the question to derive it. Okay, then moving on to the next part. Explain whether does it conduct electricity or not. So this one is actually an answering technique in the topic of acid bases. So maybe can you write now as AT first, like answering technique. Later when I teach the notes for acid bases, I'll show it to you. Yeah, so answering technique means like a nice template answer. As long as you follow, you just copy paste, right? Then you can get full marks already. Yeah, so for answering technique, like should memorize it so that you have all the keywords. But if you're the kind that you can't quite remember stuff, you want to write in your own words, can it's just I worry that you might miss out some keywords. So if you follow answering technique, your answer will be more complete. Yeah, so keywords you need to have would be number one, you need to mention about there's free moving ions. Then if can, would be good to include in context of the question, but if don't have, it's still okay. Then you can say that it acts as mobile charge carrier, or you can say the word it carry charges also can. So as long as got the word carry and got the word charge, you know. So either it can carry charge or it can act as mobile charge carrier. Okay, so I can move on, done copying, right? Okay, anyways, if you're not done, don't worry. I'm going to give you the answer key, okay? So you have the answer key to slowly write in the correction. Okay, then the next part over here, the percentage by mass. So percentage by mass, the answer is 21.2. Because you are interested in nitrogen, in ammonium sulfate, which is the right side. So for the right side, there's 2 nitrogen. So you put 2 times 14. Then over the total. So you can count on N plus H plus S plus O. You add up all of them. Then times 100%. Then done. So this will be the answer. Then chemistry, final answer, round off to 3SF. Okay, so I shall move on in 3 seconds. If you're not done, it's okay lah. I'm giving you the answer key lah. Okay, you can slowly copy down from the answer key. Okay, so I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so I think that's all for the topic on mole concept already. Yep, that's all. Okay, so yep, let's move on now to acids and bases. So for acids and bases, I will be using back the booklet. Yep, so no using of slides anymore. Over here. So can y'all flip now to 23? Yep, so flip to page 23. Okay, so for page 23 over here, for acids and bases, I will just go through the parts that y'all learn it in upper set. Those that is like lower set content, I will just skip it because I think the facts y'all should know by now. Okay, so over here need to know that for acids, there are 3 keywords we use to describe. We use the word like the basicity. So you realize how come acid here got the word basic? It doesn't mean that acid is alkaline. No. The word basicity refers to how many H plus there are. Okay, so let me then over here. So basicity is the number of H plus there are. So that's why if you look at the first one, which is HCl and HNO3, we call it as monobasic because they only have 1 H plus. Dibasic means 2 H plus. Tribasic means 3 H plus. Okay? Yeah, so basicity is not alkaline. Basicity is how many H plus instead. A bit confusing. Yeah. Okay, then second word you need to know is the strength. So strength, it would be how well they dissociate. So if it's strong, it would dissociate or ionize fully. Can you follow and copy it down? Write it in. Are you copying? Then if it's weak, that means it would dissociate partially. And this is usually represented by the arrow. So if it's strong acid, we always use a proper, the normal arrow. But if it's partial dissociate, we always use this reversible arrow, which you can see over here. Weak is always reversible arrow. And there's one concept that a lot of students always get this wrong, which is, okay, so I ask you a question. If I have maybe 10 HCl molecule, okay, so if I have 10 of them, then now if it's since it's a strong acid, right, 10 would form 10 ions, correct? So 10 HCl by right should form 10 H plus and 10 Cl minus. Do you agree? Because they fully dissociate, means all of them dissociate and form ions. Okay, so now if I have a weak acid by right, if we say weak is partially, that means maybe if I have 10 H2CO3, maybe only 5 become H plus. Then the other 5 still remain as H2CO3, something like that. That's called weak, correct? So now my question is, if I were to example the strong and the weak acid, okay, maybe I choose both mono. So I choose a strong monobasic and weak monobasic. Both of them have 1 H plus, but just one strong versus one weak. And maybe I add in metal. Then you all know, right? Metal plus acid, you will form like the hydrogen gas. So now maybe I want to collect the amount of hydrogen gas. So if I were to collect the hydrogen gas for the first reaction versus the second reaction, do you think the volume of hydrogen gas collected, is it the same? Or is it like strong acid will collect more hydrogen gas while weak acid collect less hydrogen gas? Which one do you think is it? Is it option A, the first one, which is both the volume is the same? Or option B, like the second one, that the strong one I will collect more gas, the weak one I collect less gas. So what do you think? Okay, so you chose A. Then the rest of you, what do you all choose? For those online, you can type it in the Zoom chat also. Which one would you choose? A or B? So A means both same volume. B means strong acid, I'll collect more hydrogen gas than the weak acid. So weak acid maybe like only half the hydrogen gas. So what do you all think? Any idea? So the rest of you not sure, is it? For carbonic acid, you're asking for weak basic. If both it's H plus ion dissociate from CO3 2 minus. For this, yeah, it dissociates to form ions, yeah, correct. But maybe like out of 100%, only 50% will dissociate. That's why we call it as dissociate partially. Is that what you're trying to ask? Okay, so I shall review the answer. So if I add acid, the answer is option A. A is correct. Yep, good. So those of you who answered me, you are correct. So both will still produce the same volume, but why? It's not only dissociate partially. Wouldn't I have like, out of 10, I only have 5 H plus? But here I got 10 H plus. How come here the volume of H plus still the same? The reason is because all things, we always need to reach equilibrium. Because remember, like, diffusion, it will always happen until you reach equilibrium, right? Both sides, same concentration. Same for heat also. Heat always move from a region of high to low temperature until both sides, same temperature. So things must always reach equilibrium. So same for here also. For example, at the start, if I have 10, I said that only partial dissociate means 5 of them become ions while remaining 5 stays as a molecule. So now, if I expose it to maybe a metal, so do you realize this acid, right? Acid plus metal, then I will form hydrogen gas, correct? So in this case, if I react with the acid, wouldn't this mean that my H plus will be gone? Because it will react with the metal and form bubbles and become effervescence and gone. So that means I will have less and less and less H plus as the reaction proceeds. So maybe from 5, become 4, become 3, become 2, become 1, become 0, no more. So once it becomes 0, in order to reach equilibrium, the reaction will proceed towards the right side to top up, such that, instead of 5, 0, now become maybe like 2 and 3. And so that's why I will have some of it that dissociate. So maybe this time around, I become like maybe 3 and 2. But again, same thing, these 2 will react again, and then in the end become 0 again. So now what happened? The 3 will proceed to the right side again, and then maybe become like 2 and 1. Then the 1 react again, then become like 1 and 1. You realize eventually it react away, then everything will just proceed to the right. So that means once you expose the weak acid to another another chemical, it will actually cause the reaction to proceed fully. Yeah, so that's why take note that when it's alone, yeah, it's called partial dissociation. That means only 5 will become ions. That's if they are alone on their own. Like a beaker only had the weak acid, that's all. I never add any other thing. But once I add something in, like maybe I add a metal or any other like things like carbonate or base, yeah, in the end, the reaction will still fully proceed. That's why what's the main difference between these two is only the speed of the reaction. For the strong acid, it will happen very, very fast. But the weak acid, it will just like the bubbles form very slowly, it take longer duration. But eventually, no matter how slow it is, it would still produce the same volume of hydrogen gas that the strong acid is producing. Because eventually, it will still fully proceed towards the right side. Can understand? So take note, because this is one of the very common mistakes among students. Yep, so I will, okay, instead of me, all this doodling, right, okay, wait, let me write properly so that you can like follow and copy down. So take note that for both, right, is that it will be same volume of gas produced during when reacted with something else. Okay, so usually for acid, what do they react? They react with base. Base don't have gas, sorry. React with metal or carbonate. So the key point is the word same volume. You produce the same volume, just that the speed is different. And so same volume, but different speed or rate. Yeah, so both will produce the same volume of hydrogen gas, just that strong will produce the hydrogen gas faster, while weak acid produce it slower. This one need to know. This one, a lot of students tend to make this mistake. Yeah. Okay, so done for this strong and weak part. Let's take a look at the mock exam question number 14 over here. Okay, so for question number 14, the answer is C. Answer is C. Yep, so need to know that I think you can tell right from the notes itself lah. Can I think quite self-explained. Just copy, just check the notes to do long. Yep, answer is C. Okay, so moving on to the next part here. So need to know the difference between base versus alkali. How do you know that something is a base? A base is always metal with oxygen or metal with hydroxide, which is OH. That would be a base. Then among all the base, you can further differentiate them into base or alkali. That means if I were to draw a Venn diagram, right? Base would be the overall. So we have different categories. We have acid, base, salt. Yeah, so base is a category. So within the base, there is actually alkali, which are soluble. The rest that are insoluble will remain as base. Then how do you know which are alkali? So you need to know that alkali, there is only this few examples. Need to memorize. So the examples would be the SPCA hydroxide. You know Singapore, we have this the animal foundation thing, Singapore, protection, cruelty act, something like that. It's like for animals one. Yeah, the animal abuse, then you can adopt the pets. Yeah, so for SPCA, it refers to sodium, potassium, calcium, and ammonium. Yep, so once you see these four with hydroxide, it would be alkali. Then the rest, like maybe if I say iron hydroxide, or magnesium hydroxide, any other hydroxide, or zinc hydroxide, silver hydroxide, and they will be under base. So only these four is alkali. Then the rest would be under base. Okay, so this will be the rest. I shall move on. Should be done copying by now. So here also likewise strong versus weak. Oh yeah, then need to remember the examples of strong and weak also. So maybe let me add on to the top first. Done copying, right? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the strong acids, need to remember the 3 strong ones. So the strong ones would be need to remember only got 3. The rest, you put it under weak. Okay, so weak, it would be the rest. So the only 3 strong ones would be the ones that you're very familiar law. Hydrochloric acid, sulfuric acid, and nitric acid. The rest, you put it under weak. So like what? Phosphoric acid, or maybe, in citrus fruits like lemon, orange, citric acid, also under weak. Okay, then for base, also need to remember the strong and weak. So for the base, you just need to only remember weak. Weak is only ammonia. Then strong, it would be the rest. So maybe what calcium hydroxide are also considered as strong. Done copying, right? Okay, let's move on. Okay, so next part over here, this is like the very typical example. Like if the soil is too acidic, then what do? So take note that do not add the fertilizer containing ammonium as well as the base at the same time. Why? Because if you add the fertilizer which contain ammonium and the base at the same time, what happen? They will actually have a chemical reaction. Yep. So because there's this equation of ammonium salt plus base, which is, let me show it to you over here. This is the equation there. Ammonium salt plus base, you will get ammonia gas. And the gas will escape into the air, which we do not want that to happen. Because the ammonia gas, we want it to, okay, that means plant mainly need hydrogen for healthy plant growth. So if your nitrogen escape in the form of ammonia gas, then you won't have nitrogen for the plant to absorb as nutrients. So that's why if you want to add, you can add, but don't add at the same time. So that means if you want to like neutralize the acidic soil using a base, and then if you want to add fertilizer containing ammonium, you add at different timing so that the plants can still receive the nutrients and then the soil later then get neutralized. Yep, so are you done copying all the blanks over here? Yeah, so this is what I just mentioned on that this is the ammonium salt. Then this is the base. Then you get salt, water, and ammonia gas. So for Shaza, your question on sodium oxide is an alkali? Yes, because it's soluble. As long as it's SPAN, they are soluble. So soluble means alkali. But I just put it as a category of like the base category lah. Yeah. Okay, so should be done filling in all the blanks that are highlighted in yellow by now, right? I shall move on. If you're not done, you take a screenshot. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so next part over here, need to know all the reaction. So just to reiterate, okay, how do you know if I give you a chemical formula, how do you know if it's acid, base, or salt? So for acid, you need to know that they always have H plus. Alright, so you look at the formula, you see you got the letter H for the acid. So H means acid. How do you know if it's an alkali? Alkali would be the SPCA hydroxides and oxides. And then base would be non-SPCA. But take note that they still have to be, I think, let me write clearer a bit. Okay, so it would be metal oxide slash metal hydroxide. Yep, so for alkali, it would usually the metal is SPCA. But then for base, it would be except those four. So I'll write it as non-SPCA. Then for salt, it would be ionic compound. You know, in ionic bonding, so ionic bonding, you always have metal plus non-metal, correct? So if you see a metal and non-metal like NaCl, then that's a salt. Or maybe you have cation plus anion, like maybe ammonium plus nitrate. So ammonium nitrate is also a salt. So let me test you, see whether you all understand what's going on. So maybe we do MCQ 1, 2, 3, 4, okay? So for those who are physically present here, can you point your finger and let me know? So I'm going to ask you a chemical formula. You tell me, is it acid, alkali, base, or salt? Then for those online, you can type it inside the Zoom chat to tell me. Okay, so let me choose something easy. Calcium carbonate. We always keep using, right, calcium carbonate. So calcium carbonate is under which category? 1, 2, 3, or 4? Which one is it? Calcium carbonate. Yep, the both of you answered correctly. Yeah, correct. Yeah, correct. So how was your answer? The rest of you? Yeah, Alice also correct. So the rest of you not sure, is it? Okay, so the answer is salt. Okay, so calcium carbonate is a salt because calcium is a metal. Carbonate, C and O, they are all non-metals, right? other side is a salt. Okay, then next one. What if I ask you maybe Fe2O3? So Fe2O3, which category is it under? Can you all point your finger? Yep, Joanna, correct. Yeah, correct. Okay, so the correct answer is 3. Okay, yep. So Natalie and Yushan is also correct. Yep, so the answer is base because Fe2O3, Fe is a metal with oxygen, so it's a base. Yeah. So then maybe I test one last one. What if I test you, let me think. KOH. KOH. So what is it under? KOH. So what's KOH? Yeah, correct. Yeah, RJ also correct. So what's your answer? Yeah, correct. The answer is KOH is alkali because K is potassium. So potassium hydroxide. So it's an alkali. Also, that's how you tell like it's like acid, base, alkali, also. Okay. Then next part over here is just like in case you want to learn like ionic equation, just jump a little bit another chapter. Yeah, so ionic equation, this would be the shortcut because the spectator ion it is the N ion, it will get cancelled off. Then take note, okay, that whenever you have this reaction, how to remember it? Okay, by right, I think you should have remembered it from lower sec. But if you can't remember, I have this mnemonic to help you called MASH. You know, like you mash things up, like maybe mashed potato or something like that, or maybe mash music up, something like that. So Ma form SH. So metal acid form salt and hydrogen gas. Okay, so MASH, mash. Then take note that usually when you have this reaction of acid plus metal, we usually don't choose the super unreactive ones. Why? Because the unreactive one don't react, right? But besides the super unreactive ones we don't choose, there's also some other metals that we don't choose. Do you all know which is the other metals that we shouldn't choose? Correct, the overly reactive ones. So also don't choose the group 1 metals because group 1 metals are too reactive. Yep, so can you add it in? So don't choose the very reactive metals, which are mainly the group 1s. Yeah, so group 1 metals are very reactive. Yeah, those will be very dangerous. You put in and there will be like explosions. Yeah, so shouldn't choose the overly reactive. So we always choose the mid tier law. The not too reactive, not unreactive in the middle. Done. You'll finish copying the blanks, right? I shall move on. Okay, so I'm moving on in 3 seconds. If you're not done, you take a screenshot bar. 3, 2, 1. Okay, moving on. Okay, then next part over here, for the reaction with carbonate, this one to remember, right? I have this mnemonic called cash, money. Yep, so for cash, it will be C for carbonate, A for acid, S for salt, H for H2O, and then carbonate confirm form carbon dioxide, right? Already got the word carbon, so obviously you will have extra carbon dioxide. So it's just cash plus carbon dioxide. And so this is a way to help you to remember. Yeah, so usually at tuition, I usually teach students on ways to help them to remember to make like their studying life easier. Yep, so the rest, I think all these you all should know. All these are just like from your notes. Yeah, just go and study it. Then the next part over here, it would be acid plus base. So this one, the mnemonic I have is called BASH, BASH2O. Yep, so BA form S and H2O. So take note that the common product is the salt, okay? So water is not a common product because when you look at mesh equation, metal reaction is hydrogen gas. So take note, water is not the common product. Salt is the common product because all 4 got salt. But not all 4 got water. Okay, then I shall move on. Should be done copying by now. Scroll down a bit. The top one can, right? Yeah, scroll down until here. Okay, then the last one, it would be the alkali plus ammonium salt. You get salt, water, and ammonia gas. All this I think you all should know. So one of the key points to take note is that, just now I mentioned to you, right, that ammonia gas is actually an alkali gas. That's why it would turn litmus paper blue. So need to know, okay, that ammonia is actually weak alkali. This one we written it previously in front already. So just remember it, but just repeating. Like that. So all this ionic equation, if you're wondering how to get, right, you can just write out the spectator ions lah. Then just cancel, cancel, cancel. You will get this answer lor. Okay, so let's take a look at the mock exam paper, question number 15. Yeah, so those of you who haven't do it yet, can you take a look at question 15? So how was your answer for question 15? Have you done it? Okay, so I shall review the answer. So for question number 15, the answer is A. Why? Because in this case, how do you get, they say that it's acid plus metal. Remember I told you the two scenario where we should not have acid and metal, which is either the super reactive or the super unreactive. Remember, these are the two metals that we shouldn't be using. And this time around, they're asking for not, that means we should not use super reactive or we should not use super unreactive. So among here, copper is unreactive. That means we shouldn't be having copper plus the acid, which is, you can tell like it's hydrochloric acid. Yeah, also that's why option A is the answer. Because you shouldn't be using copper to get copper 2 chloride, because this is a reaction with the metal. Okay, so done. Answer is A. Okay, then back to the notes. Done with the annotations, right? I move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, then the next part over here would be all this y'all should know lah. So I don't want to go through any further. Okay, so I skip to this part on titration. So for titration, usually there is this pH curve, right? So just wanted to emphasize to you that for pH, for titration, usually you will hear words like equivalence point, you will hear words like end point, correct? So do you realize both equivalence point and end point all refers to, okay, my reaction completed liao. So my reaction ended, right? Then I should record the result. But what's the difference between these two words? Like, why is there like end point and equivalence point when both refers to the ending? So do you all know what's the difference between end point versus equivalence point? You all know what's the difference? Okay, I asked my own student. Okay, I asked Alice then. And so Alice, what did I say in class? What's the difference between equivalence point and end point? Hey, wait, you are not in my chem class. Okay, ask Jadine. Okay, you're in my physics class. Okay, so Jadine, what's the difference between equivalence point versus end point? Do you know? You're not here. Correct. Yep. So for end point is for practical. When you do practical, you know, when you have a color change, isn't that the end point? So end point is referring to color change where you use this word during practical. Equivalence point is when you use it during theory, because equivalence point comes from the word equal, meaning like equal in terms of concentration. Yeah, so equal concentration of your H plus and your OH minus. And only in theory we can calculate the number of moles, correct? Yeah, so you can calculate a number of moles or concentration like mole per dm cube. Yeah, so all these mole calculation are all in theory, so that's why it should be a word used in theory. Okay, so both also refers to the end of the experiment, just that one for theory, one for practical. Okay, then next part over here. So for the equivalence point, you just find the steepest part, then you pick the midpoint. That will be the equivalence point. And need to know how to read the graph, because you need to know what is your starting in reagent in your conical flask and what is in your burette. So to tell, you go by this. You look at the initial pH. So initial pH tells you what is inside your conical flask. As compared to this number here would be the final pH. Can you write it in? So need to know these 3 points. Initial pH, equivalence point, and final pH. Final pH would be what you contain inside the burette. Yeah, so this is when you spam a lot from the burette. That's why you see the pH is like, oh, now I know. Okay, in my burette, I have a strong alkali because the pH is very high. And then my conical flask, I have a strong acid. So if both sides are strong, in the end, what happens? If, example, 2 players at the Olympic, both are equally strong, most likely the result of the match will be a tie, a draw, correct? So same for over here. If both are strong alkali and strong acid, the equivalence point will be in the middle, which is the draw, pH 7. But you see over here, if it's weak acid and strong alkali, obviously the stronger player will win, right? So then your equivalence point will be at the stronger side, which is the alkali side. So can you see the equivalence point is pH 9, is at the alkali side. And then over here, likewise also, if weak base and then strong acid, then overall the strong will win. Also, you see the equivalence point is at the acidic region below pH 7. Okay, so yep, done for this part. Let's move on. Okay, so what I just mentioned is shown over here. Next, need to know the different types of oxides. So for oxides, generally, I would say that first, I will classify them whether is it metal or non-metal first. Yep, so if they are metal oxide, I can further differentiate them into amphoteric or basic oxide. Yeah, so only 3 of them is amphoteric, which I remember it as a Z. Yep, so for Z is amphoteric. The rest of the metal would be under basic. Next, for non-metals, it would be either neutral or acidic. So same thing, need to remember the neutral oxides, which is these 3. Then the rest, you put it under acidic. Okay, so that's how you can remember. Like go by metal, non-metal. Then remember 3 on each side. Yeah, so remember the 3 metals and the 3 non-metals. Then the rest, you put it under acidic or basic. Okay, so all this I think you all should know, like what does it react with. So I shall not cover anymore. I shall move on. None popping, right? Okay, so moving on to the next page. Yep, so it will be next, it will be on salts. So this table over here, usually I see students always struggle like, I cannot remember which one is the exception and stuff. Okay, so I have techniques to help you to remember. So this is how I teach my students also. Yep, so how you remember is, okay, I think the first few, your teacher should have taught you before, the span, right? Okay, I mean no space on the left side, I write on the right side. Yep, so for the first 4, I think you all should know span. This one your teacher teach before, right? So span means S for span, S for soluble. So as long as you got sodium, potassium, ammonium, and nitrate, it will be soluble. Then over here for the chlorides and iodides, okay, usually they tend to test chloride more often. Iodide, very seldom. So how to remember which are the exception? It would be by, I'll go by the mnemonic called CAP. Yep, so CAP meaning the chlorides are all soluble except Ag and Pb. Can, so you know where CAP? CAP. CAP. Okay, then next would be sulfates. How to remember which are the exception? I'll go by this. S for sulfates, S would be soluble. So the sulfates are all soluble except the triple sizes. So what are the 3 sizes that you all learn? What are the 3 sizes that you all learn? What do you all learn? What are the triple sizes that you all learn? Biochem physics, right? So you base on bio, chem, and physics. How to remember? B for bio, you put letter B first. C for chem, you put letter C. P for physics. So first try, you go by alphabetical order. Let's try put letter A first. So if I put letter A, got such thing, right? Barium. I put letter A, have, right? Calcium. Got PA or not? I don't think periodic table got PA. So A doesn't work. We move on to the next alphabet. After letter A is B, right? So I try with B. Oh, can. That's lead. Okay, done. Okay, so that's how you can remember. So S for sulfate. All sulfates are soluble except the triple sizes. Okay, then next is carbonates. How to remember for carbonates? Carbonates will just follow the norm. Follow the norm meaning it would be all of them are insoluble except the spar over here. Because spar is always soluble. Done. So it's like quite easy to remember actually, with all the mnemonics and tips and tricks. Okay, so I shall move on. Done, right? Okay, then moving on to the next part would be salt preparation. So how do you know, like maybe I give you any chemical formula like calcium carbonate or maybe like magnesium sulfate. Yeah, so any salt that I give you, how do you know which method to choose? So there are 3 methods, right? The 3 red color ones: precipitation, titration, and excess. So you go by this. If your salt, you check with the solubility table above. So of course you need to remember solubility table first. If you don't remember solubility table, You can't even do salts question. You can't even do chemical equation. You can't even do ionic equation. Yeah, so minimally must remember the solubility table. So first, you check based on the solubility table above. If it is insoluble, then you carry out precipitation reaction. Yeah, because precipitation is to form your precipitate, right? Which is your solid. Yep, that's why precipitation, must remember, is a very iconic equation, which is aqueous equals, you get solid aqueous. Okay, so it's always like that. This takes symbols. But if your salt is soluble, then you check, is it SPA or not? SPA meaning sodium, potassium, ammonium. Okay, in case you forget, I write down over here for you. Sodium, potassium, and ammonium. So as long as your salt don't have these three, you will do the add excess method. But take note, whenever you add excess, it's excess solid, not excess acid. Why? Why cannot the other way around? Because I know that metal will react with acid, whether excess acid or excess metal, they can still react. Why cannot the other way around? Anyone knows? Does anyone knows like why I cannot put the other way around? Why must be excess solid? Why cannot excess acid? Have you ever thought of that? Or just, okay, teacher say like that, just remember.
The soluble salt.
Then?
Then you can't really differentiate. Like, I can't really separate the acid and the salt before parts.
Yes, very good. That means you got understand. That's good. Yep, because your salt is soluble. That means your salt is aqueous, right? Then you all know that acid also aqueous, right? If you got both of them, it's like liquid form, both are aqueous. How you separate them? It's like very difficult to separate. You want separate can maybe you do what fractional distillation, but it's a very complicated process. What I mean, but fractionating column, this and that, it's very complicated. Yeah, so that's why usually we tend not to have excess acid. It's because it's very difficult to separate from your salt. Yep, so can you write it down since you all don't know about it? Yeah, so it's very hard for you to separate out from your salt, which is also aqueous. Both are aqueous, very hard to separate. That's why we add excess excess solid. Why? Because excess solid, it would be easy to separate, right? Because if you have solid to separate from liquid, you can easily separate using which method? What's the method? Filtration, correct. Because filtration very easy, just take a piece of paper, can now. Just have the paper trap all the excess solid on top. Then your filtrate would be your salt solution, because your salt is in aqueous form. Yeah, so that's the reason why you must put the correct way. Okay, then next, also need to be able to recognize that these two reactions are kind of similar actually. These two reactions are all your acid-base chapter equation. Remember just now we had all the equations? Yeah, so this one just refer to acids and bases topic will do. Yeah, so in acid bases, remember I taught you what bash, cash, mash. Then you see over here, this is the cash, Ca form SH. Then this is the Ma form SH. Over here also BaSH, CaSH. Yeah, so you see cash, bash, mash. But between all the equations, how do you know where do you put? You base on solubility. If it is soluble, you put on the left side. Because you know, right, titration need to be all in liquid form. Your burette pipette must all be in soluble form. Yeah, so that's why out of the three equations, soluble ones you put on the left, insoluble ones you put on the right. Okay, so I'll write it clearly for you. So this side it would be the soluble reactant, starting reactant. While right side you put all the insoluble reactant. That's why over here they mention the word insoluble solid. Yeah, so that's why you see acid plus carbonate, it appears on two sides. Can you see left side got acid plus carbonate, right side also have. Cause soluble you put on the left, insoluble carbonate you put on the right. Acid plus base also. Then you see acid plus alkali, acid plus base. Yeah, so that's why it's just based on the solubility. Then done. Then after you carry it out, you need to obtain the salt. Yeah, so for titration, since your salt is in liquid form, right, like aqueous state, you need to do crystallization to obtain it. And usually we choose crystallization, not evaporation to dryness. Do you all know why? Why do we do crystallization and not evaporation to dryness? Okay, I shall review since you all never say anything. Okay, so one reason is because I think you all know, right? What if the salt is not thermally stable? Like it might decompose. And second reason is because crystallization has higher purity than evaporation to dryness. So evaporation to dryness not so pure. But one good thing is very fast. Of course, you just blast the Bunsen burner, it will be very hot. Okay, so I'll just write it down over here. Usually, we don't carry out evaporation to dryness. Why? Because we're not sure about its thermal stability. Because you can't possibly go and memorize every single salt, stable to heat or not, will decompose or not. You can't memorize for every single salt, right? Yeah, so that's why don't do evaporation. As well as evaporation to dryness has lower purity. Crystallization more pure. Yeah, so crystallization has higher purity. So crystallization would be recommended, although it might be slower. Okay, so next would be for the insoluble solid to acid. This one you all know, right? We already said, use filtration law to separate out the excess solid. Yes, Jeline. Cannot hear. What if you want to decompose? Why? No, as in we don't want, usually we don't want things to decompose. Because I still want my salt. If it decomposes, then it becomes something else really. Yeah, so I don't want it to decompose. That's why I shouldn't use evaporation to dryness. Because evaporation to dryness, you blast until totally dry, it might decompose. So I don't want it to decompose. That's why I do crystallization, which is still wet. Yeah. Okay, then for precipitation, I think you all know, right? Because you have the solid among all the liquid, of course you do filtration to scoop out all your solid precipitate. So Adviata is asking, is copper sulfate crystallization forming an insoluble salt? So for copper sulfate, sulfate is S for sulfate, S for soluble, except the three sizes, right? So sulfate is actually soluble. So you say insoluble salt, then it's incorrect already lah. Because copper sulfate is for soluble, not insoluble salt. Okay, so let's move on. Okay, so for the next part over here, oh wait, this is an exercise. Okay, so can you all give it a try to see whether are you all able to fill in the blanks? Yep, so you give it a try, bah. So you fill in all the blanks. So you follow this flow chart on top to decide what you should fill in. So it's not anyhow mix things. Like for example, like you see, like titration and add excess must have acid. Yeah, lor. So if you were to choose titration or add excess, make sure you must have acid. Yep, so can you fill in the table below? Yeah, the exercise table. For Clara, yes, all base have a metal because the definition of a base is metal oxide or metal hydroxide. Let me show it to you again. Over here, can you see? Metal oxide, metal hydroxide. So base definitely have metal. Yep, so fill in the table below, the exercise box below. Yes, correct. It's ammonia, not ammonium. Ammonium is neutral. Ammonia is an alkali gas. Yeah, so I would say, yeah, ammonia is one exception that doesn't have metal, correct? So at Viata, you're asking about the separation techniques chapter, right? So it's because for copper sulfate, it would decompose upon heating. That's why we do crystallization and not evaporation to dryness. So once you do crystallization, your solid crystals will be stuck at the bottom of the evaporating dish. And on top, you have the liquid. So that's why in order to collect the solid at the bottom, you have to pour it into a filter funnel so that you can collect your copper sulfate crystals in the filter paper. That is why we need to filter. It's because to separate out from the saturated solution, we want to collect out the copper sulfate crystals. Okay? No problem. For this lesson, I think maybe some of y'all might find that I'm a bit like too fast, or some of y'all might find that I'm a bit too slow. It's because I'm now teaching like a big like class, like there's so many of you online. Yeah, so I have to like teach it like in the middle pace lah. Yeah, but usually like for my own classes, usually I'll see the strength of my students, then I'll adjust the speed accordingly. So A is asking, is calcium compound soluble in water? Calcium compound, you have to look at your anion. Yeah, so that means like because you have to follow the solubility table. So what is tested within your syllabus? The possible calcium compound they can test you is only calcium nitrate, because SPAN, N are all soluble. Calcium sulfate, like what you mentioned, insoluble. Calcium carbonate also insoluble. they will also ask calcium chloride because in the solubility table above, there is the chloride. So calcium chloride would be soluble. So they won't test you with any other anion. The other anion, you're not required to know because they only test you within the syllabus. Yeah. Okay, should be done by now. I shall review the answer. Can you check your answer? Let me know which one you want me to explain. So which one do you all need me to explain to you? Which one that you all got it wrong? Yeah, I think I shall just go through everything. Since I asked you which one you got it wrong, you don't tell me. Okay, so for the first one over here, so first you always check the solubility, right? You follow the flow chart. So for lead chloride, just now remember I told you to remember for chlorides, you go by CAP. Yep, so all chlorides are soluble. Okay, so all chlorides are soluble except Ag and Pb. So that means this is insoluble. So now you follow the flow chart. If it's insoluble, immediately you can choose precipitation, right? Because precipitation is to obtain the insoluble salt. Yeah, so that's why you choose precipitation. And precipitation, if you look at the equation above, is aqueous reacting. So that means you must have starting two, both must be aqueous. So that means you must have lead something that is aqueous, and then you must have something chloride that is aqueous. So the easiest would be you use the SPAN, because SPAN will always be soluble. That's why you see here they use the S, and then here they use the N. You want to use potassium also can. So that means other possible answer is like potassium chloride, ammonium chloride. Yeah, because as long as they are soluble, will do. Then here, you put nitrate, because nitrate confirm soluble, so it's the easiest to choose. Okay, then next part over here, if they give you, this one is very obviously is acid, and this is a soluble alkali or carbonate, right? And they even tell you that it is titration. So for titration, that means you are supposed to get the spa salt. Can you see over here? Titration is spa salt. That means your salt must have spa, also P, because of the potassium. Then, and the Cl from acid over here. Just the usual equation, you know the Bash Cash Mesh equation? So this is the Bash or Ba, base, acid, or cash, Ca, carbonate and acid. Then you get your salt. Then the last one, it would be zinc nitrate. So same thing, you check the solubility. Remember SPAN. N is always soluble. So if it's soluble, does it have spa? It's non-spa. So in this case, if it's non-spa, you follow the flow chart. Non-spa would be the at excess. So this time around, you must make sure your solid, you must have a solid and acid. And I told you, right, must have acid. Yep, so you just follow the equation above, must have acid. So you must have acid plus either metal oxide, metal hydroxide or carbonate. Metal oxide, metal hydroxide or carbonate. Then the method would be just copy lor. Done. Okay, so I shall move on, should be done with correction by now. Okay, then the next part, it would be qualitative analysis. Oh, wait, before I move on to qualitative analysis, can we go through the answers first? Let's take a look at the MCQ question number 15 and 16. Wait, 15 is, okay, 15 is like mixture of acid, base, and salt. Okay, I go through 16 then. Okay, so 16, the answer is not by titration, the answer is strontium carbonate. Why? Because remember, carbonates are always insoluble except the norm. Yeah, the norm, it is your SPA or SPAN. Yep, so that's why in this case, this is insoluble. Then cannot, because you know, right, titration, your burette and pipette, and then your end product, your conical flask, all of them are all in liquid form. They are all soluble. That's why it must be soluble. But here is insoluble. So that's why cannot. This one, you see, this is the SPAN. Soluble is always SPAN, right? Yeah, so this is your A for ammonium. This one is this is group 1. So group 1, it will be soluble because S and P, sodium, potassium, they are all in group 1. Group 1 are all soluble. That is P right there. So you see, they are all group 1, all soluble. That's why strontium is eliminated. Done. Okay, then I move on to the next question. Done copying, right? Okay, then the next question is open-ended question number 3. Open-ended question number 3. Yeah, over here. Oh wait, this one I went through just now already, right? Okay, that's settled. Okay, can. Then let's continue on with the notes. Okay, so next part over here on qualitative analysis. Okay, so how to remember, right? Usually my students also find it very difficult. Wow, like the table so long, sometimes soluble, sometimes insoluble. Then like how I remember soluble, insoluble, right? Like confused, right? Okay, so how to remember, right? There's a method to remember. You go by this. If you see amphoteric, right? Like, you know, just now I went through what the amphoteric oxides. So amphoteric oxide was the Z, which is over here. There, amphoteric. So you know amphoteric, it has this dual personality, right? It can react with acid, can also react with alkali. So if it can react with both ways, that means when you add in excess, it can also change its personality. So maybe from got precipitate, which is insoluble, later can become insoluble. Yeah, it can change its identity. So that's why you see, this is the one that is originally, it is insoluble, because it's precipitate. Suddenly it become soluble. Do you see that there is a change in identity? Yeah, so there's a change in state. Why is there a change in state? Is because these are amphoteric. Yeah, so for amphoteric, they are able to change between acid and base. Yeah, so because of its ability to change, that's why the result can also change. Yeah, so that's how you can remember. So the rest that is like maybe like what calcium or like any others that is not amphoteric, like maybe your iron, copper, when you form a precipitate, usually it will just remain there long. So that means it will remain insoluble. It won't change insolubility. Okay, so only amphoteric can change insolubility. So that's the way to remember. Another way to remember is only transition metals got colors. Do you all fill in the colors? Yep, so for copper, you all should know because you all learned before copper sulfate is like the blue crystal, right? So copper is always blue. Then for iron, how to remember which is green and which is reddish brown? You need to know that iron is actually formed in rusting. So if you want to rust, you know that metals over a long period of time then will rust, right? Brand new metal, where will rust? Yeah, so that's why it's only after a long duration then will rust. So for iron, you need to know what? Iron first, you will form Fe1 plus, then become Fe2 plus, then become Fe3 plus, right? So the thing is, to reach 3 plus, it takes the longest. And rusting takes very long. That's why you can think of the rusty color, which is reddish brown, to be the last stage. That's why the stage before is not reddish brown, not the rusty color. The stage before, it will be green color instead. Okay? Yeah, so that's the way to remember. Then the rest on the precipitate is just white. Only these three transition metal got color. The rest are all white color. Okay, then next is for the aqueous ammonia. So aqueous ammonia, it would be that this is another way to remember. So instead of remembering ion by ion, this way is to remember like which are the ones that are same observation. Yep, so you need to know that whether it's soluble or insoluble. Yep, so for the aluminium, it will remain the same. It won't change its identity anymore. Then zinc will follow on top. Yep, then the color will follow similar to above. So it's pretty similar. You all fill in the blank ready for the table over here? Okay, then next is there is also the test for ammonium ion, which is you add sodium hydroxide and warm it. So take note, okay, that whenever you add sodium hydroxide, right, it can test different things. It can test for cation, it can test for ammonium, it can also test for anion. Do you know which anion also add sodium hydroxide to test? Which is the anion that you can test using sodium hydroxide also? Nitrate. So need to know that there are three things that can be test using NaOH. So let's write out. So if you only use NaOH, you will test for cation. If you use NaOH plus warm, isn't it over here? Plus warm, this would be to test for ammonium ion. If you use NaOH plus warm plus aluminium foil, that would be test for nitrate ion. So be careful, okay, that sodium hydroxide can also test for anion. Yeah, because a lot of students always see that, oh, NaOH, okay, test for cation. Then they always forget about the nitrate. So don't forget about the nitrate. Okay, so I shall move on, should be almost done copying. Okay, then the next part over here would be the test for anion. So for the test for anion, most of it, I think you can just go by this. Okay, so how do I know if something is present is mainly based on whether is the, can I form precipitate? Because you see, if my solution is colorless, then I say that, okay, that thing is present. But if it remains colorless, I cannot see what. If you cannot see it, then how you know it is present? So the whole logic, okay, so how the chemist design the table for cation and anion, like just on the table, right, the test for cation, and this table, test for anion, they all design with one thing in the mind. I must produce a precipitate when something is present. Okay, so that's why in order to form a precipitate, you just follow the solubility table. So for example, like if you want to test, okay, this one you all should know lah, right? This one is the acid plus carbonate equation. So like for example, how do I know if sulfate is present? You follow the solubility table. Sulfate, you need to either form barium sulfate, calcium sulfate, or lead sulfate. Okay, so out of these three, who should I choose? Okay, so this time around, they choose barium sulfate. Why? Because if you were to choose lead sulfate, it is a bit confusing because you need to know that for lead can actually combine with sulfate and chloride to form insoluble. So lead sulfate, yeah, you can form precipitate. But what if the precipitate is lead chloride? Yeah, so that's why like if you see precipitate, do you know is it sulfate present or chloride present? You cannot differentiate ma. So that's why we tend not to use lead because you do not know if it's sulfate or chloride present. Next, just now we saw also, right? Another sulfate that's insoluble is calcium. So why do we not use calcium? Is because happen that because your test for cation, usually they will introduce calcium. Yeah, so the thing is that you don't introduce extra calcium in already. Because what if maybe the solution they want you test for calcium, then you go and add calcium sulfate. Yeah, then you add calcium sulfate, then like the calcium, is it originally inside or is it you add one? That's why because your test for cation include calcium, so we exclude calcium so that we know that if any calcium is present, it's because the original solution already have. It's not because I added in. That's why we also don't use calcium sulfate. Yep, so that's why in this case, we will end up choosing barium instead. Yeah, to have barium sulfate to form your right precipitate. Yeah, so I write down over here. So we also don't choose calcium. We don't choose lead. It's because calcium because of the test for cation table have already. Yep, so don't choose calcium, don't choose lead. You choose barium. Okay? So that is why they add in barium to form your precipitate. Same for this two also. You choose silver is because silver can form precipitate with chloride and iodide. Because remember the solubility for chloride is the cap. You wear cap, the cap. Yeah, so for cap, it is actually chlorides are all soluble except the Ag and Pb. So these two are the exception. And remember I told you, don't use lead because you can't tell. If you add lead in, is it chloride or is it sulfate? You can't tell who is present. That's why the better option is you choose silver. So that's why they add silver in. Okay, so the aim is all just to form the insoluble salt, which is your precipitate. Okay, so actually this whole table is designed related to your solubility table. Okay, so I shall move on. Should be done copying by now, right? Okay, then the last one I already went through with you just now, is the NaOH, but must plus aluminium foil plus warming also. Done. Okay, so then the last part over here, test for gases. This one I leave it to you to study on your own because most of it I think you all should already know, even learn it from the website some more. Yep, then reminder over here, just remember, okay, litmus paper must be moist if you're testing for dry stuff because you need to be dissolved in water, then can dissociate to form your H plus and OH minus ions. Yep, oxidizing and reducing depends. If your school haven't teach redox yet, then you can skip this part lah. Yep, then this one is another chapter. Okay, so let's go through the question stated here, which is MCQ question 17 and 18. Yep, so Sam, wait, let me show the other copy which has the answer. Hold on. 17 is here. Yep. So 17 is A. 18, sorry, I don't know why I got two color. 18, the answer is D. Oops. Okay, so answer is A, then D. Anyone need me to go through any of it? 17 or 18? Need me to explain? Oh, you got it right. Oh, then that's good. Don't need to go through, Okay, then we move on. But if you need to go through, you must tell me. If not, I will just skip. Because since you all got it right, then don't need to go through. Okay, sure, I'll go through 17. Okay, so for question 17 here, which reagent could be used to distinguish hydrofluoric acid and nitric acid? So you can go by chlorides. Because remember, we actually learned how to test for chlorides, right? Which is the test for anion table. So you can use silver nitrate. Because silver with chlorine, it will form insoluble salt, which is the precipitate. So that's why you use silver to react with chloride. So you can write down silver with chloride, you can form AgCl, which is the precipitate. Yep, so that's how you test for the presence. Sure, I'll go through question number 18. Okay, so moving on to question 18 over here. So in this case, you just check the notes. They said that you have white precipitate which did not dissolve. So remember, I told you only amphoteric can change its identity, right? From precipitate, which is solid, it can change its identity. So since it did not dissolve, that means it is not amphoteric. Yeah, so if it's not amphoteric, remember amphoteric is the ZAP. Yeah, so ZAP you eliminate. Then next, this would be the aluminium foil. Remember the N, just now I was telling you, right, to write down the three of them. NaOH is to test for cation. NaOH plus warm, it would be to test for ammonium. NaOH plus warm plus aluminium foil, it would be to test for nitrate. So that's why the answer is D. Okay, so moving on to the next one. Done copying, right? Not much to copy anyways. Okay, so the next question related to salts is open-ended question 2 and 3. Open-ended question 2 and 3. Huh? You all check your answer. So when question, take note, okay, of the instruction word. When they ask for identify, you can write the chemical name or the chemical formula. But if question were to ask you to name, right? Okay, so if the instruction word use the word name instead of identify, take note, this one only accept chemical name. That means if you write chemical formula, right, all your answers wrong. So in the end, if they ask you to name ABCD, and then you write chemical formula for all four, 0 marks. So remember to take note of the instruction. Or if they say that right now, state the chemical formula. So obviously, if they say chemical formula, then it would be formula only law. Yes, so cannot write the name if they say state chemical formula. So only identify, then you can choose either one. Okay, so need to read the instruction carefully. Okay, so take note that for transition metals, do you remember to include the Roman numeral? So must include the Roman numeral. Okay, so can I check among all these here, A, B, C, D, and part B, any parts that y'all would like me to explain to you? Any parts to go through? Oh, you can get all the answer. Oh, then that's good. Really, don't need to go through. Then I will move on. Because if you need me to explain any of it, you tell me now. If not, I'll just move on to the next question. Okay, it's a good sign that you all can get it right. That's good. Okay, then in that case, I finished going through for salts already. So let's just quickly run through all the answers for overall. Done checking, right? I changed the screen now, okay? Okay, so here's the answer for the MCQ. Can you all check through your answer? I'll show the first 10 first. Come, can you check your answer? If you didn't manage to receive the information that you are required to do the mock exam before coming for class, then I'll recommend you, why not you just shade the OAS sheet. So you shade the OAS sheet, then at your own time, you can go and do the questions in the question paper, right? Then you check with the OAS sheet as if like it's an answer key like that, no? Yeah. But if you have completed, then that's good. Yep, you check your answer first. Yes, the answer key will be sent to you at the end of the lesson. Sorry, I think my lesson might overrun a little bit. Yep. So if any of your parents are like, fetching you after class kind, maybe you want to let your parents know that like to come a little bit later. Yeah. I think I'll like end only at like 1:15 maybe. Yeah. Yeah, let's go down to the next half. It should be done by now. Yes. Yeah, can you maybe get from your friend the answer key or something like that? Yeah. Okay, so I shall go through the answer now. Okay, come. Let's go through page by page then. Okay, so we start off with the first page of the MCQ. Okay, so for this page over here, anyone need me to go through any of the questions here? Question 1, okay. So for question number 1, they're asking you which method is suitable to collect hydrogen gas. So you should know that hydrogen, the mass is very small, right? The MR is only 2, so obviously it would float. So if float, it will float up. So float up, then go up. That's why you choose option 2. Next, for hydrogen, you need to know that hydrogen is insoluble. How to remember? The way that I teach my class is how to remember soluble or insoluble, right? You go by this. Hydrogen, you will see effervescence, right? Remember in the topic of acid bases? Yeah, you form like effervescence of hydrogen gases, right? And so since it's effervescence, that means it didn't dissolve. If it's dissolved, like for example, like salt. Salt dissolve in water, salt will dissolve and disappear, right? So if disappear means can dissolve. Since it didn't disappear, it stays as bubble. That means insoluble. Yeah, so insoluble means you can do the displacement by water method because it won't dissolve here and will be collected at the top. Okay, yeah, so that will be the answer. Okay, then moving on to question number 2. Over here, it would be the kinetic particle theory topic. So you need to know that for the movement, in order to shrink means that you want the gas to come out faster than the gas going in. So if you want the gas to come out very fast, that means the gas that is inside, which is X, it should be of a smaller relative molecular mass. Yeah, so that small and lighter, it will be able to diffuse faster. So this would be faster diffusion. Then as compared to Y you want it to go in slower. Slower means it should be larger mass. Because heavier, it would move slower. So that means you just need to check periodic table for the mass for all of them. Then of course, basic formula need to know lah. If you don't even know the formula, then you can't even get the answer already. Yep. So need to remember all the gen, they are all diatomic. Yep. So oxygen, nitrogen, hydrogen, as well as halogen. Halogen is group 17. All the gen, they are all diatomic. Means something 2, like O2, N2. Just press calculator lah. Then you see, you choose the one that is left side smaller, right side bigger. Then it will be the correct answer. Done. Okay, so moving on to the next page, question 3, that page. Question 3 to 5. Which question do you all need me to go through? Oh, by the way, just to let you know, if your school doesn't cover the transition metals for the SPDM notation, then there is no need to do question number 4. Yeah, because question number 4, they include transition metals. So depends. Some schools only test the first 20. So if your school, like I think like NY and RGS, you're not tested on the transition metals, then question 4, you can skip it lah. Okay, so this page, any questions to go through? Question 3 to 5? All good? Again? Yeah, 3 and 4 is SPDM. I think your school don't cover lah, so you don't need to do this. Yeah. Okay, I shall move on since no question. How about question 6, this page? Any question to go through? Question 6, okay. So for question 6, they are asking you electrons not involved in bonding. It would be 2 types of electron. One, it would be the inner shell electrons, as well as number 2, the valence electron that is not bonded. So the valence non-bonding electrons. So let's take a look at chlorine. Chlorine, you all know that it has 17 electrons, right? And can you see that only 1 electron is involved in bonding? So that means there is 16 that is not involved in bonding. So that means for this part here, I will write down for chlorine, it will be 16 not involved in bonding. Then hydrogen, you only have 1. And obviously that 1 electron, you already bonded. So all the hydrogen, no more leftover electron. For carbon, you know that it has 6 electrons, right? And out of the 6, 4 valence involved in bonding. You only left with inner shell 2. That's why it will be inner shell 2, and we have 2 carbon. That's why times 2. For oxygen, you know that it has 8 electrons. And out of the 8, you have 2 involved in bonding. So 8 minus 2 is 6 electrons. So you add up 16 plus 4 is 20, 20 plus 6 is 26. Any more questions for this page? All good? Okay, then we move on to the next page. Yeah, we will just go through page by page. So moving on to this page, on question 8, this page, any question to go through? So all good. That's a good sign. Okay, then we move on to the next page. This one, like, I went through the whole page, is it? I went through already. Next page, have I went through the whole page also? Also went through the whole page. Okay, then we continue on. Question 17, this page. Need to go through any of it? So Audric say question 20. Okay, I'll go through question 20 over here. So this is on the topic of periodic table. So if your school don't teach periodic table, then you don't need to do this question. Yeah, so like for RGS, don't need to do periodic table. Okay, so they said that element X is found in group 17 of the periodic table. What is the likely behavior? So they say that it can react with oxygen to form an oxide which react with a base. So they are trying to say that group 17 is non-metal. So non-metal with oxygen, isn't that non-metal oxide? So then based on the notes, let me show it to you. Just now we mentioned, right? Non-metal oxide. Where's non-metal oxide? Hold on, let me try to find. Don't know which page is it. Let me make it smaller. Yeah, over here. Non-metal oxide. Then remember, non-metal oxides are acidic. Yeah, so that's why in this case, if it's acidic, yep, it will react with a base. So you can write down that group 17 is non-metal. Yep, so it becomes non-metal oxides are acidic. Yep, that's why it will react with base. Any other questions for this page over here? Yes. Okay. Question 7. Okay, maybe if you have any more extra MCQ, maybe I go through later because I don't want to overrun. So maybe Loi and Jadine, you can stay back. I can explain to you individually later. Okay, so I shall move on. Okay, then moving on to the open-ended. Yep, so this is the answer. So for the drawing over here, depends on your school. Some of your schools, like I think NY don't need the square bracket, right? But then like RGS need the square bracket. Yeah, so you follow what your school teacher say. If need square bracket, you put square bracket. If don't need, you can remove it. Yep, so key points to take note is that must include the electron of another symbol. And can you check the charges? Are they correct? Okay, then next part over here on the difference in melting point. This one take note. Take note. This is very important. Because I have students that write the answer. Well, content everything correct, right? That write so long, right? The 2 marks gone. Why? When content everything is correct. The reason is because the answering technique. When they ask you for difference, right? Take note. You cannot just write down, okay, first whole paragraph, I write everything on sodium chloride based on what I remember from school notes. Then I write another whole paragraph on chlorine below, 2 separate paragraphs. Like that, right? Even your key points, everything correct, right? 0 marks. You won't score at all. Why? The reason is because you need to show the difference. Whenever they ask for difference, you need to always compare point by point. Yep, so you cannot just write one whole paragraph on the first one, then one whole paragraph on the second one. I don't see any comparison. It's just 2 separate paragraphs. So what do I mean compare point by point? So number 1, you can actually maybe compare about maybe the structure and the attraction. Forces of attraction. Yeah, so you see, like for example, like the first one, you say that it has giant ionic lattice structure with strong electrostatic force of attraction. While the other one, you use the word simple molecular structure with weak intermolecular force of attraction. So you see, you compare on the first point. Then later, you can compare on the second point. So second point, it could be about the energy to overcome. Yep, so that's why you can say that, the energy to overcome, is it more or is it less? Yeah, because one is stronger or one is weaker. So you talk about more energy required to overcome. Then the third point, you then state about the boiling melting point. I scroll out a bit. Oh, they don't have the boiling melting point. But you can also conclude with a final statement on like which one higher, which one is lower. So besides comparing point by point, another skill that you need to have would be you need to remember to use comparison words. What's comparison words? It's like higher, lower, but, while, however. So they use such words. Yep, so that's why you see in the answer, they use words like while, then they also use the word like more. Yep, so use such words though. For Shahana, the recording won't be sent to you personally, but it will be uploaded on OVERMUGGED YouTube channel eventually. Okay, so I shall move on. So if you're not done with correction, no worries. As I mentioned, at the end of the lesson, I'll show the QR code of the answer key. Then you can slowly write in your correction. I think for now, it's just more of like, you write down the annotations. Because all these annotations is not in the answer key. As well as like, if you've got a question, you should ask. Then you can mark your paper to see how many marks you can get. Yeah, the correction you can slowly copy at home. Okay, so I shall move on in 3 seconds. 3, 2, 1. Okay, moving on. So next part over here, same thing. As long as this is like, they ask for boiling point or melting point, you can use the answering technique. Let me show it to you. I change to the notes for a short while. Sorry, give me a while. So if you were to go to the notes on the bonding, right? Let me show it to you. Then over here, can you see? So over here, we have summarized it very nicely for you. So exam, like, the last minute revision, like in the morning time, I just revise over here. So you see, you need the what structure, strength, then like, all the properties, yeah, I've written over here, including the answering techniques. Like if they ask you, can you describe, how ionic bond forms between Na and Cl? Or maybe like, can you explain, like, you see just now the question about boiling, melting point, or maybe the one that I just went through, like electrical conductivity, you see, I've written out nicely for you. So these are answering techniques, answering templates. So if you follow these templates, you write it in, right, you'll get full marks. So these are the parts that you need to play your part in studying. Like you need to remember all the key points. Yep. So then, yeah, using the answering technique. So this would be the answer for the below part. But this is an application question. So obviously you need to include more. So how do you test if something can conduct electricity? So you mainly check like maybe you can like set up an electric circuit where you have two, like maybe, okay, if you don't know what's carbon electrode, you can put wires lah. You dip two wires in, have battery, have light bulb, ammeter. Yeah, then you see if the light bulb can light up or the ammeter got reading, that means the object is able to, that means there is the solution is able to conduct electricity. Yeah, like that. So that means there's the application part plus the answering technique. Okay, can you write down the word AT at the side, like answering technique? Yep, then you can also write down the page number. You can refer to the notes page. This is notes page 14. Yeah, so you can write down all that to refer to notes page 14. So AT, then write down page 14. Okay, so you just refer to the revision kit page 14. Then, okay, so I shall move on, since you all will be having the answer key. Okay, then next part over here, this one I went through just now already. Then this question I also went through already. Oh, there's a part D. I realized I forgot to go through just now. Okay, come, let's check your answer. So they're asking you for the chemical formula that is of the anion that is present. The answer is carbonate. Yeah. So the explanation would be as shown over here. Because if you want the, yeah, because above is that if you want to have the reaction of barium chloride to be formed, it will be either barium sulfate or barium carbonate precipitate. Because if you refer to the salt solubility table, remember all sulfates are soluble. So S for sulfates, S for soluble, except the 3 sinuses. Yeah, so the 3 sinuses is barium. So this is insoluble. Then carbonate also, all carbonates are insoluble except SPA. Yeah, so this is under the salts, just on the salt solubility table, under the salts chapter. Yeah, so since they are insoluble, then they would form the precipitate. Yep, but then you realize that, oh, the precipitate dissolve when you add acid. And we know that acid will react with carbonate, right? There's such equation, right? Remember the Cash equation. Carbonate plus acid, you form Cash and carbon dioxide. So that's why since it will dissolve, that means it contains carbonate. Done. Okay, so I shall move on. You all can slowly copy the correction at home, then I'll give the answer key later. Okay, so moving on to this question here, this is an application question. Yep, so you can check your answer. Okay, I can only, okay, let me make it smaller. Can I fit all? Yep, can. The first few should be okay lah, because it's just copy notes, just refer to the trend above, then just state. So should be quite straightforward. Okay, so over here, state and explain the relationship between the bond energy and the strength of the acids. Yeah, so generally, if the bond between them is very, very strong, obviously you need more energy to break the bond, right? So that's why the higher the bond energy, then is the weaker the the higher the bond energy, the weaker the acid. The reason is because, okay, hold on, let me scroll down a bit. Oh yeah, true. Because if you cannot break, that means they don't dissociate. If they don't dissociate, that means they dissociate partially. That would be weak acid. Yeah, that's why higher bond is weak acid. Because they cannot dissociate. Yeah, like that. Okay, so I shall move on. I will give you the answer key anyway, so you can slowly copy it at home. So can understand the logic behind it, right? Because if very strong, you cannot break, cannot dissociate. Cannot dissociate, that is weak acid. Okay, so moving on to the next page over here. So as long as it is an ionic equation that involves both aqueous, acid, and alkaline, you can just write this. But take note that this is a shortcut. This is only for soluble acid and soluble alkaline. That means if your acid react with an insoluble base, then it doesn't work, okay? If it's insoluble base, you cannot write this. You still need to write out spectator ion, you cancel. The answer won't be this. This is only if starting both are equal. So this is like a shortcut answer. Yeah. Then take note, this one is a weak acid. Weak, you need to use the reversible arrow. Then the last part, state and explain whether is it possible to have same pH. The answer is yes, because you play with the concentration. So a concentrated weak acid can be same pH as a diluted strong acid, because the concentration of H plus can be equal. The same, do you have the word same concentration of H plus? Then make sure you have this part over here.